Hey everyone, welcome to this AZ-104 V2 Study Cram. I created a version of this a couple of years ago. It just passed 1 million views, so I thought this was a pretty good time to update it. There's actually not been a huge amount of change, but still there have been some modifications. There's been a few things removed and added. So, hey, I thought it was a good time to go ahead and update. Now, I do have in the description links to the different sections of the knowledge, so you can absolutely jump around. My recommendation is to make sure you actually go and do the activities. So make sure you've gone and looked at the study guide, for example. So if we jump over, go and look at the study guide, and it breaks down what all of the different areas that you're going to need to study are. So be able to have gone through this and tick all of those different things. Get hands-on and actually go and try them out. Again, I am only going to cover the theory about it. There's just too much for me to try and show all of the hands-on. Go through the learn modules. So if we actually go and look, you can schedule obviously the exam, but if you see the ways to prepare, it has this self-paced and it has fantastic learning modules that covers all of the knowledge you actually need to have. Now, I also have my AZ-104 playlist. I have links to my Azure Masterclass V2 where I go through the detail of that as well, which is linked in the description. But really prepare yourself in the best possible way. Try out the technologies. The new applied skills give you an environment you can try various types of the technologies. In a lot of those self-paced learning, there are labs that again gives you a chance to get some hands-on. So the administrator exam is really about knowing how to do the various things. So make sure you've equipped yourself in the best possible way and have actually gone and tried these things out. Try it from the portal, try it through the CLI where templates apply. Make sure you've done it through all of those things. So let's dive into the areas. And the first one I want to talk about is Entra ID. Now, this used to be called Azure AD, but it's been renamed. So if I think about Entra ID, well, this is the identity provider from Microsoft. And what's going to happen is the whole point of Entra is it speaks cloud. So if I think about the regular types of protocols we're going to interact with it, well, it's going to be things like OAuth 2, OpenID Connect, which is all about identification, so authentication, authorization. Speak things like SAML, WSFed. And the key point of all of these things is these are useful to speak over the internet. It's using HTTPS, TLS encryption, so it works just over the internet. I don't require a whole bunch of ports that I would typically have on a private network. Now, that's very different from what we're used to with on-prem. So if I think about in our on-prem world, what we would typically have is, okay, I've got my Active Directory domain services where we have all of those domain controllers. And then it speaks things like Kerberos, NTLM. And if I want to interact with it, I use things like LDAP. Over here in Entra, if we want to interact with it, we have things like the Microsoft Graph. So the graph is really now the standard way that we interact with many of the things like Office 365, yes, Entra ID. And with this, it's all REST-based calls. And again, that's going over that 443, that HTTPS. So the whole point is this is an identity provider that speaks cloud compared to your Active Directory domain services that's really structured for private networks with lots of different ports available. Now, Active Directory also has organizational units. It has a structure to it. We do not have that in Entra. Entra is primarily flat, but we will talk about something called administrative units to help delegate at a more granular level different types of permissions. Now, it is very common that we want to replicate from our Active Directory domain services to Entra. And the key point here is the flow is always that way. Active Directory domain services is essentially the source of truth, and I'm replicating into my Entra ID tenant. Now, there's different technologies for this. There's really two. So it's going to be Entra Connect, and one of them is Entra Connect Sync. Now, with Entra Connect Sync, the actual engine runs on premises. So my engine is down here. The other option we have, and I'll do this in a slightly different color, is Entra Connect Cloud Sync. And as you might guess, in Cloud Sync, the engine runs up in the cloud, and I have these very lightweight agents that would run, for example, on my domain controllers. So it's the means to be able to communicate, but the engine that's actually working out which identity links to which and creating and updating with Cloud Syncs, it runs in the cloud. With Entra Connect Sync, it runs as an application I run on one of my Windows Server instances. But again, it always flows that way. Hey, I have an account in my Active Directory domain services, and it is going to replicate to and create an account in my Entra ID. So this is the key point. It's always flowing that way. And what's really nice about this, obviously, is once I have this cloud identity configured, well, what do we want to do with it? What we would then have is applications will trust our particular instance for their authentication purposes. So I might think about, well, there's obvious ones. There's things like Azure. There's things like Microsoft 365. And they're all going to trust a particular instance for its authentication and its authorization. But also there's a huge amount of third-party SaaS applications. So they would trust it as well. And one of the recent things we're seeing is, we think of this secure services edge. Well, I can also now have checks done for any internet site through internet access feature, and even any TCP or UDP app on premises and control it through Entra Private Access. There's different ways to extend that. But the key point is, I have my instance, and then different services will trust it for its authentication, for its authorization needs. Now, I drew this idea of Entra ID. What's actually happening is you as an organization will have a particular tenant. So think of that as your particular instance with its users and its groups and its devices and its applications, all of that, its conditional access policies. So in my example, mine is going to be saviltech.net. That is my instance of it. Now, by default, when you create one of these things, let's just have a quick look. So if we go and look in my example, close these tabs down. If I look at my Entra tenant, I've got kind of my overview page. We can see my name, and we can see here my primary domain is saviltech.net. So what I have done is I have added a custom domain. Let's do show more and look at our settings and domain names. What you'll always have by default first is it will be something.onmicrosoft.com. And then you can go and add your own custom name. Now you have to verify it. You have to go and create a record in your zone to prove, hey, I own that domain name. And then once you've done that, it will now enable me to make that a usable name within my Entra tenant. And I can then use it as part of my users and even make it the primary. So we can see here, I changed my primary to actually be that custom domain I added. So I have full capabilities around that. Now, one important thing, people often get confused when we think about Entra ID, or Entra tenant and Azure and subscriptions. A tenant does not live in an Azure subscription. It's not an Azure service. It's a global instance. It's just available to us. And then I take a subscription and I trust a particular tenant. But this does not live within the subscription. That's really an important thing to understand. And then I can do different types of branding. So within my particular tenant, one of the things, if I went and looked, for example, at my user experiences down here, we can see I have the idea of company branding. And I can tweak a lot of the interface. So I can configure different backgrounds. I can configure background images. I can set messages, for example, when they log on with some special characters that do things like bold and underlined. So I can customize a lot of the experience around that. Now, within my particular tenant, I'm going to have accounts. So I can think, well, here, if I look at all my users, there are accounts that I create in my tenants. They would be cloud accounts. So here I could, for example, look at this is my on-premises synced. This is no. So this was just created directly in the cloud. So this is a cloud account. Other of my accounts were synchronized. So this is a hybrid. It was created in Active Directory domain services, and then it was synchronized up. I also have the concept of guests. So a guest is coming from some external instance or other identity provider. So here there's an example of a guest that comes from a different Entra tenant, but I might also have ones, if we look down here, well, this one came from Google. I could have ones coming from Facebook. I could have ones coming from some other SAML. I have one here coming from a Microsoft account. So the whole point around this, and the reason we have this, is yes, I can have accounts that are native to my organization, and either they're hybrid or I create them in there. But realize I might also be very commonly interacting with users from other organizations. And I don't want to create them a separate account because that's a horrible experience for them to have to remember a different password, and they probably wouldn't. They would use the same ones, and then it's a security risk if I have this same password in lots of places. It's painful for me to have to be able to reset their password. It's painful for their company that if they leave, they have to talk to me to disable their account. And so what we have, therefore, is this idea of external users. So if I think of external, now by default, they would be guests within my tenant, but they don't have to be. I could make them a member, which impacts certain ways policies are applied, for example. But I can have external users. And when it's an external user, it has a little kind of stub object that refers to their primary identity, but their primary identity still lives out here. So that could be, hey, a different Entra ID tenant, could be a Microsoft account, could be, as we saw, Google, Facebook, SAML. There's other options available. I can just do it from a one-time code that I email to them, which would still prove they owned their mailbox. So different things I can do, but we're going to end up with all of these accounts in our environment. So I have the ability to synchronize accounts. That's obviously a big one. I can create them. I might get them provisioned from an external system. So I talked about, hey, my Active Directory is the source of truth, but maybe it isn't. My source of truth actually could be some kind of HR system. And what there are a number of, actually I'm going to move this out of my way. There are a number of actual provisioning endpoints that Entra provides. One is for some specific HR systems, one is for APIs, but my HR system may actually talk to this kind of provisioning endpoint, and it then goes and creates the accounts. But it's clever enough that even if I'm talking to the Entra provisioning endpoint, it could actually go and create it in Active Directory first through these connectors, and then it will go and replicate it into Entra. So it's really nice. So I could create them here, replicate. HR could provision them, creates it. I can bulk create. So if we go back to that portal, we saw here the idea that I'm talking about, hey, users, and I can absolutely here create a new user from scratch. I could invite an external, so business to business. But notice there's also this idea of bulk operations. I can bulk create, bulk invite, so bulk invite people from other organizations, identity providers. If I do the bulk create, what it's going to do is give me a CSV template. I edit it and then I upload it, and it will go ahead and create all of those accounts. Now, obviously, I could also write my own scripts. There's various things that I can do here. But the whole point is there's many ways I can actually go and provision my accounts. Now, I talked about users, but we also have groups. Because if I think about it, most of the time, I don't want to give a permission, so a role or a set of access to different files to individual users or even licenses. It gets very cumbersome to manage. So what I typically am going to do is I'm going to create groups. So I want to create these groups that could have different things, could be devices, and then I add users into those groups, and then I grant the role, the permission, the license to the groups, and then I'm not worried about, oh, I forgot to remove something from a user or left a license behind on the user. So ideally, we want to use groups for a lot of those types of interactions. And there's two types of groups. So a group could either be, if we look down here, we have security and Microsoft 365. So security is going to be the most common type. That we can actually assign it to roles. Microsoft 365 type groups is we're going to use it for collaboration tools, calendars, SharePoint, etc. And then, well, I can either assign membership directly, so I specifically pick certain people or certain devices, or I can do dynamic. With dynamic, that's one or the other, users or devices, I just select rules, and then it's going to periodically check, well, who should be in this group based on, or maybe if their display name contains something, or more likely, hey, you're in a certain department. You have a certain job title. And then I can pick various values, and it will then populate those groups. If I looked at all of my groups, for example, you can see it shows me, is it assigned or is it dynamic? And notice I've got a couple of dynamic ones here. So I've got based on the group hire date. So maybe I have a group that, hey, only include people hired within the last 30 days. Is a good example of that. I have one for iOS devices. I have one for my Justice League. And here, if you went and go and look at my definition for this one, so if you look at my properties, we can see, hey, it's a security, it is dynamic user, and I have my dynamic membership rules. And all I'm looking for, does the job title match hero wildcard? So it could be hero or heroine. So I've got different things I can use in there. And then once we have those groups, notice I could assign it licenses, I could assign it to applications, I can assign it roles, and that's going to be our preferred way to do that type of management. Now, the other thing we have, obviously, is devices. And we're used to the idea that in the past, we'd always just join our devices to the domain. But one of the things we're trying to shift to, especially for the desktop, is, well, it could be anywhere. They could be working from a coffee shop or home. I don't want to have to establish always a VPN so they can talk to a domain controller. So one of the things that is now very common is we want our devices to interact directly with our Entra tenant. And we have two options for this. So one is we register. Now, if we register, it becomes a known entity, and we can do certain management. So it will show up. I can apply policies. I could use Intune to manage it, for example. The other one is we can join it. Now, I would think about use register if it's a user's own personal device, but they want to talk to corporate applications. Register would be appropriate for that. We still want to do certain validations as the company to make sure it's not being jailbroken, it's healthy. Join would be if it is our corporation's device and I want absolute control over it. Because now, in addition to these things, so it's all of this, and I can actually authenticate with those accounts. So at logon screen, hey, I'll log in directly with my john@saviltech.net. And so obviously now these machines show up as well as objects in my particular Entra tenant. Now there are different licenses when I think of Entra, and I can grant them at a per user level. It doesn't have to be everyone in the tenant has to have exactly the same license. There's different levels of license depending on which functionality I actually want. Now I'm going to talk about the Entra ID licenses, but realize many times they are bundled with something else. Hey, I've got Microsoft 365 E5. Well, I get the P2 license. If I've got the E3, hey, maybe it's the P1. But if we look at the licenses, the key point here is you get different sets of functionality. Now there's free, and I actually get a good amount of functionality with that, but then we go up to the P1 and the P2, and there is also now a governance add-on, which adds things like lifecycle workflow capabilities, and that's going to add on over time. We can go and see the different pieces. So obviously that identity governance also has some new types of audit reports. So you've got entitlement management, verified ID, lifecycle workflows, governance dashboard, machine learning, certifications and access reviews that I was talking about. But what you really see here is P1 adds key things like conditional access. And that's a huge deal to this HR-driven provisioning. Hey, that's a P1 feature. And then P2 adds the richer features like privileged identity management, the core access reviews, the identity protection features. So we can go down and see all the different types of functionality we have. You can see the identity protection, different types of self-service. Hey, a lot of that I need P1 for self-service password reset with right back to on-premises, hybrid identity. So there's these different versions. And once again, I might have different licenses for different people. It's not that everyone has to have the same one. Maybe my more privileged users, well, they need a P2 because I want privileged identity management. I want that stronger identity protection, although the identity protection is really useful for everyone. But then maybe there's some more basic workers where I just do the P1 license. And then some of them, I want the lifecycle workflow add-on because they're using those richer lifecycle capabilities. So I can adjust, and again, typically we'll assign those to particular groups of users. It's not going to be the same for every person. And then I talked about self-service password reset as a feature. So that's a really nice capability. People will forget their passwords. Now, ideally, you're moving to password-less solutions. We want to try and get rid of the password as much as possible. But where they do have that, for cloud accounts, hey, we can just reset our password. For hybrid, again, if we have that write back capability, that P1, we can reset it and it writes it back down to here. And we can pick different options for how that password write back will work. If we go once again and look at our users, and then in here, if we, where's it gone? Look at all my users. Password reset down here. I can configure exactly what options I want to do. So who is enabled for password reset? And then the authentication methods, hey, is it just one of these types of things? And I can include custom questions. Or, hey, I want you to go through 2 of these to be able to go and reset your password. So this saves the help desk being pinged every time someone forgets their particular password. They can just automatically retrieve it themselves, provided they've set up that self-service password reset, which you'll prompt them when they first join the organization and log on for the first time. Now, while I'm in here, we talked about roles. There are a number of key roles as part of this. The big one is global administrator. So global administrator, you really want to restrict who has this because it is the most privileged role. But there are many others, so I could pick certain delegated sets of permissions I need for particular roles. And notice it is calling out, hey, these are privileged. So this would give you an indication of, hey, I want to be careful of who I'm actually giving this to. Now, I mentioned the idea that Entra is flat, but then I also mentioned administrative units. So here we have administrative units, and what this lets us do is create these units. I can then put in users, I can put in groups, I can put in devices, and then at the particular administrative unit level, I can grant roles. So hey, for this particular group of users, I could then grant someone a particular role. So I can actually go through and, hey, I want to pick one of these roles and grant it, but it would only apply to the objects in that particular administrative unit. It wouldn't apply just in general. So this is the way that I can be more granular in who has permission over which particular users or groups or devices. And a key part to here, and it makes a lot of sense if you really think about it, if I add a group to an administrative unit, I do not give permission for a role set of that admin unit for the users in the group. I would have to specifically add the users into the administrative unit as well, because otherwise, imagine I had privileges over an administrative unit, and really they just wanted me to do group management. But if it also extended to the people in the group, well, I could add people in the group to then get permissions over the users. We probably don't want that. So I would have to explicitly add the users into the admin unit in addition to the group if I wanted people to be able to manage the users as well. So that's really a safety feature there. Okay, so moving on from the identity side, and obviously identity is key. We always think of identity as that first security perimeter in the cloud. Now let's actually start talking about the cloud. Now, one of the first concepts you'll see when you use this is, well, there are actually a number of different clouds. We always think about Azure, but that Azure Commercial is one of the clouds. If I was to jump over to my VS Code just super quickly, and what I'm running here is this idea of, so I'm using PowerShell and the PowerShell module get AZ environment. So the different clouds are also known as environments. Notice it's showing me 3 clouds: the Azure Commercial Cloud, the Azure US Gov Cloud, and then Azure China. Now there are others. There are other more secret instances for government agencies. So they're not publishing the different URLs. But notice a key point here is each of those environments has a different URL for the control plane interaction and for talking to Entra, so talking to what was the Azure AD. So when I think about these different clouds, well, they have their own Entra sets of tenants. I can't use the same tenant between Azure Commercial and Azure Gov or China. They're different instances, and then they have their own regions. And so when I deploy something, I deploy it into a region. So let's draw a particular idea here of a region. So this is region 1. Now within this region, there's going to be a whole set of different data centers. And very commonly what happens is, and we're going to talk a lot more about this, they get divided up into this idea of availability zones, AZ1, AZ2, AZ3. Once again, we're going to talk about this, but think of it as different sets of data centers. And when I deploy a resource, very commonly, I get this choice of, do I want it zone redundant? So I can say, hey, zone redundant. And what that means is it spans the availability zones. My other option very commonly is I can make it zonal. If it's zonal, it exists within a specific availability zone. And so that's when we think about resiliency within a particular region. And we always want to make sure we don't have dependencies on things outside of the region, outside of our availability zone. And there are a huge number of these regions. So for example, if I jump over for a second, this is a nice little pretty map of Azure. Let's just look at the flat maps, maybe a little bit easier. And I could pick, notice the different types of regions we have. But if I drill down, so I can see West US, West US 3, West US 2, West Central, Canada Central. So there's regions all around the world, all of these little blue dots. There's even giving me information about sustainability and other cool stuff. There's huge numbers of regions. And when I talked about those availability zones, I can see which ones have availability zones through here. Now, the goal, I think, is eventually all of the regions will have availability zones. And it's always going to be 3. A subscription only ever exposes 3 availability zones. The physical location may have more sets than that, but you are always going to see 3 when you look at your particular subscription for a particular region. Now, realize things can happen. There can be natural disasters. So what we want to do is we should always be using at least 2 regions. So if I think about, hey, there's another region over here, we'll call this region 2. And we want to pick them such that this distance is huge. So I want to think about, hey, I want hundreds of miles, maybe 100. It's going to vary, obviously, depending on where you're using, how big the landmass is to be able to spread them apart. But we want them a large distance. If there was some natural disaster or problem here, it wouldn't impact this as one. And Azure actually pair their regions. Now, the pairing is being de-emphasized for many things, so you get more choice. Like a lot of the databases, you pick how you want to replicate. Even storage accounts now, I have a certain amount. I can do object level replications. But if you think about rollouts deploying through Azure, they go to their internal systems, they go to their early access, the canary regions, they go to a pilot region, broader regions, and then the first one in a pair, and then the second one. So by using paired regions, you make sure as Microsoft rolls out its safe deployment practice, well, if I have things in paired regions, they won't get the same change at the same time. And those pairings are detailed in documentation. And they're always going to try and stay in the same geopolitical boundary. So we can see, well, Australia sticks to Australia. Brazil is the one exception because Brazil South replicates to South Central US. South Central US does not replicate to Brazil. This was because originally Brazil only had one region, so it had to replicate outside of it. But for everything else, they always stay in that same geopolitical boundary. And we can see that through this map. Notice the gov clouds, they stick to other gov regions. And we can go and see that detail, exactly what those pairings are. Again, you do not have to stick to those pairings only. You do have choices. But for things like the safe deployment practice, that absolutely does roll out using those pairings. So if I don't use the pairings, well, then, hey, there is a chance that the same change applies at the same time. Now, they still try and roll it out AZ by AZ, but there's a certain risk you are taking there. So we pick our regions typically based on where we want to consume the services from. Like, that's the whole point. I have all this choice. I can get instances of my service close to where I'm consuming it, so I get the lower latency. And again, think about those maybe data sovereignty requirements of that. But what we actually deploy into is a subscription. So if we come back over here for a second. So I've got my tenant, and my tenant's there for a very valid reason. Remember, our subscription is going to trust a very specific tenant. But I think, okay, well, I'm going to go ahead and I'm going to have a subscription. So let's say I have my subscription 1. And this is where I'm going to go and deploy my different resources. This can help me organize my resources. It's a boundary for some resources like virtual networks. And I can actually create a hierarchy because I'm going to want to do other things. I'm going to have governance requirements. I'm going to maybe want to track budget. I'm going to want to assign roles. And very often I may want to do that at a higher level that encompasses lots of different subscriptions. And so what we do is we have this management group structure. Now, our management group structure actually starts at our particular tenant. So tied to our tenant, we also have a root management group. Now, under that root management group, I can go and create my own hierarchy of management groups. It could be based on geography. It could be based on business unit. It could be based on prod and non-prod. Where am I going to want different policies? Where am I going to want different roles assigned? Where might I want to track budget at different levels? So I can go and create these different structures based on what makes sense for me. And then ultimately, subscriptions will tie in at a certain level of that. And we can see these. So if we go and jump over, now I'll go and look in the Azure portal. I can see my management groups. And we see we have our tenant root group. Now under that, I have one subscription tied to it directly. Then I have a child management group called All Saviltech subscriptions. If I open that up, well, I've got 2 subscriptions under that management group. But then I have 2 further child management groups. And at these management group levels, if I was just to pick one, notice we have access control. Notice we have policy. And notice we have budgets. So these are really the core 3 things that I want to use those management groups for. So if I think about what might I be doing that I need to do, well, very commonly, what I'm going to want to be doing is, sure, grant roles at certain levels. So I may want to apply role-based access control. I might have governance requirements to say, hey, you can't use this type of resource. You must have this agent installed. You cannot use these regions. So that's governance that I want to set guardrails in place. Well, that's Azure Policy. And then I also may have financial requirements. So I have budgets. Well, I can set these as well. And when I set any of these, they're inherited. So if I was to set a role or a policy or a budget at this level, it would apply to every child thing underneath. Then likewise, I can set all of these at a subscription level. I could set a role. I could set policy. I could set a budget. And we think about we'll be more generalized the higher up we are, because it applies to more things. As we get closer and closer to resources, we can get more specific with our particular requirements. Now, when you're playing around with this, you can get free trial accounts. There's a lot of services that are always free. In your company, they may have an enterprise agreement, and you could maybe go and get a subscription there for non-prod use. But if you're starting out, if you're playing around, you can absolutely go and get a free trial. Now, a huge point of the cloud is it is consumption-based. You pay for what you are using. And so you always want to be really careful that you don't leave things running you're not using. You try and optimize to pick the right type of SKU for exactly what you want to do. But you can go and see this stuff. So if I was to go and look, notice I have, for example, cost analysis. But I'm just going to go and pick a certain subscription. And I have my cost analysis in here. In the main menu, you also have this cost management and billing. And so that's the primary place you can go. But notice in my cost analysis, it shows me, well, what I've spent. And then it's showing me the idea of a forecast. Now, this is accumulated cost, but I could also do, for example, cost by resource, daily costs, cost by service. Instead of an invoice, I could just pick this month. It's showing me my budget line again. It's showing me my forecast. So based on my current spending, this is what it thinks. So it's showing me my forecast. I'm going to end up spending. I can get detail based on the type of service, the location, the resource group. And there are smart views. If I was to look at my resources, smart views will actually look at what I'm doing, and it would detect things like, hey, this particular resource group is 24% of your cost. There are other insights. It would detect, hey, 15% of my cost. Am I got any anomalies based on how I normally spend money? Well, there's something a bit off around this. So I have a lot of flexibility in my cost analysis. I can go and add additional tabs to look at resource groups. I can look at my daily costs, which will then show it by the different resources. So I just have a lot of control over here. When I do think about optimizing my cost, realize Azure Advisor is also your friend. Here there could be recommendations about cost. I don't have any, but there are a huge number of different areas it would recommend. Stopping resources, right sizing, lots of different aspects to this, but it would also recommend about reliability and performance and operational excellence, security. So you want to go and review this at least weekly. But one of the other things I can do on that budget side, if we jump back over, is, well, I can go ahead and set up budgets. So a budget is going to enable me to set a certain amount of financial unit, say dollars. So I can set that amount. And then what I can do is once I go ahead and configure that, now I've done one already, I can then go and set alerts. So alerts can be based on the amount I've actually spent. So, hey, if you hit 80%, go and call a certain action group, which we're going to talk about later on, but it could be an SMS message, call a webhook, call a function, lots of different things. Or it can be based on forecasted. So based on the current trend of the rate of spend, if it looks like I'm going to pass 120% of my budget, hey, I want you to go and do this. And I can add alert recipients as well. So budgets are super useful to be able to not just track my spend, because I can track as well. Notice it's showing me based on a particular budget, how much I've spent so far and what do I forecast to spend. But I can also set thresholds to do things at certain amounts of that. So that's a really useful capability, both so to get insight and to raise awareness by kind of pinging me to say, hey, do you mean to be spending this much money? Now, when I create a resource, while it does live in a subscription, there is another level that we actually deploy into. So within a subscription, what we actually do is we create one or more resource groups. So I can think about, hey, within this subscription, maybe I've created resource group 1. I would have other resource groups as well. Now, you cannot nest them. Might have resource group 2, might have resource group 3, etc. And once again, all of these different things, well, I can apply RBAC and policy and budget here as well, which makes sense because I may want to be even more granular with very specific policies or particular roles to now only a subset of the resources. And that's what I create in here. Now I'll actually go ahead and create my resources. So maybe it's a virtual machine, maybe it's a storage account, maybe it's a load balancer, whatever that might be, I go ahead and create my resources within a certain resource group. And the way I want to use them is think of using a resource group for resources that will get provisioned together, that will run together, that ultimately will get decommissioned together, i.e. deleted together. So those resources together provide a certain set of functionality. Maybe it's a certain business application. So yeah, it's got a bunch of VMs or a Kubernetes environment and a load balancer, maybe a database. They form a unit. And the reason we want to put them in the same resource group is, yes, for tracking the resources, but also most likely they're going to want a common set of role-based access control. I may want to apply a certain common set of policy. I may want to track the spend of that particular application. So, hey, let's put it in a resource group together. So that is a very logical thing we want to do. Now, I guess while I'm talking about spend, I showed budgets, and budgets are great to control the cost of the Azure resources, and we try and optimize by picking the right size of resources, stopping them when they're not running. But there are also some financial things that are purely about how much we're billed. So if I think for a pure money perspective, I'm going to use dollars, could be gold bars, whatever you're currently being billed in. There are different aspects to certain types of resource and the money I pay. For example, with a virtual machine, if I think of a virtual machine, yes, I pay money for the compute resource, the virtual machine object itself, but realize, well, that VM also runs an operating system. So if that's Windows Server, if that's Red Hat Enterprise Linux, well, that costs me money as well. And maybe I'm running software inside it that costs me money. So for example, if I'm running Windows and then maybe I'm running SQL Server, they all have cost elements to it. So one of the first things we can do is we have something called Azure Hybrid Benefit. And the idea of this is it's basically applying to licenses. So if I have existing Windows Server licenses, it could be standard or data center, if I have, for example, software assurance on those, I can bring and use them in the cloud. Now, if it's standard, I have to move it to the cloud. If it's data center, I can use it in both at the same time. But I can do it for SQL Server. I can do it for Red Hat Enterprise Linux. So this would apply and remove the Azure consumption cost of this part. So that would save me money. I also have the option of something called Azure Reservations. And this is very specific. So this would be for a very specific service in a very specific region. So I have to be super specific, but it will save me money for that very specific service for that very specific location. And then we have something called Azure Savings Plan. Now, Azure Savings Plan is very flexible, but it's only for included compute services. So a bunch of virtual machine types, most of them. I can do things like Azure Dedicated Host. I think it's the Premium V2 or V3 app service plans. There's different things it applies to. And for both of these, typically it's a 1 or 3 year term. So I'm committing to say, hey, either I'm going to use this type of storage in this region for 3 years and you get a discount. Or this is just, I'm going to spend $20 per hour for the next 1 year or 3 years and I get a big discount. And we can see this in the pricing calculator. So let's quickly over here, do I have one open? Yeah, so I've got virtual machines, perfect. So if this was Windows, notice it shows me the different breakdown for the license cost and the compute cost. So if I was to bring Azure Hybrid Benefit, the license cost part has gone away. If this was a SQL VM, notice now there's 2 bits of licensing cost. Maybe I've only got Azure Hybrid Benefit for the OS, or maybe I have it for SQL as well. Those parts all go away and I'm only paying the compute charge. And then for the compute charge, well, reserved instance, we get a discount based on if it's 1 or 3 years. So let's say a 3-year. And I can pay it monthly or I can pay it up front. Or I do a savings plan. Now notice the savings plan discount on this SKU is a lot less. If I picked a better, newer SKU, so let's try V5. Notice now the savings plan discount is better. So the savings plan discount varies by SKU and type of service. And the way the savings plan would apply is every hour, it's a billing mechanism, it wakes up and it will try and apply the best discount it can first to whichever resource is running and then sort of kind of go down. But I can only have one or the other. It's savings plan or it's reserved instance on a particular resource. But if I looked at, let's say, a storage account, so a storage account, I can do reserved instance, but there's no concept of savings plan. A savings plan only applies to those particular included compute services. So these are pure financial options. These are not about shrinking a VM or anything around that, stopping. It's, hey, I've got stuff running. How can I financially try and reduce my bill? Now, leading on, and it does tie into the cost, is very often, great, we're organizing things into nice hierarchies and subscriptions and resource groups, but we may need to know additional data about a certain resource or subscription or resource group. We may want to be able to filter down based on certain metadata, so key value pairs of resources. Maybe we'll even use it for billing purposes. So one of the other things we can do is we can apply tags. Now I can set tags at subscription levels. I can set it at a resource group. I can set them on resources directly. And I can even do RBAC on resources directly. We don't like to, it's too messy. But tags are just key value pairs. It's normally 50 tags per resource or resource group, but they are not inherited. So that's an important point. If I set a tag at the subscription, it does not get applied also to the resource groups and the resources. If I set a tag at the resource group, it does not get inherited by the resources as well. Now, I could do things with Azure Policy to copy them. So here in my dev subscription, I have tags. I could add tags to it. So I've got environment dev. I could look at resource groups. And if I pick a resource group, well, I can apply tags. If I was to look at a certain resource, I can apply tags. Again, it's just key value pairs. Notice this one, hey, I want to be able to know who the owner is. That's really useful for tracking. I've got something useful for me just to track what OS version it is. Hey, the environment, the cost center, the business unit, all things that might be useful for me to later on. If I was just, for example, browsing my resources, well, notice I could add a filter and I might use, for example, the certain tag down here that, hey, only show me things where the cost center is demo group 1 or something. So I can use it to filter my views. I could use it for billing purposes as well. It's a really useful capability, but they do not get inherited. Now, if I used Azure Policy, and we're jumping ahead a bit here, but I just want to point it out. And if I look in my categories and just search for tag, one of the things you will see here are things like, hey, inherit it from the resource group if I'm missing. I can inherit from the resource group anyway. I can inherit from the subscription. So there are various things we can do to force resources to take from the parent, but it's not the default behavior. By default, I have to have it set on the particular sub or resource group or resource. But if I needed to, hey, I can modify those things. Speaking of Azure Policy then, the whole point of policy is in ye old days, if I wanted to create a resource, I would go to the operations team and say, hey, I need this resource. They would maybe check a bunch of standards for the company. And if we met them, it would approve it. In the cloud, I just go and self-serve. I go and create it myself. There is no person in the middle of that interaction. And so Azure Policy lets us set those guardrails to configure our requirements, but I can also go and then track compliance for those various policies. So if we jump back over again, and we look at policy, well, you can see straight away on the overview, I'm tracking my compliance. For the policies I do have, I can see well, what they are, and I can see how compliant am I for the ones I've configured. And then we have definitions. So these are all the definitions, and they're built in. I can create my own. And then we'll see there are initiatives and there are policies. So a policy is a specific condition I'm looking at, and then a particular effect I want to apply. So for example, if I was to look at my ones, I have a policy. So allowed locations, for example, well, all this is doing, if we look at the definition, is it get past a parameter of which locations is allowed. And then my rule says, hey, the field location and what I'm trying to create, if it's not in the list that I've set of allowed, or it's not global, then I'm going to have a certain effect. And in this case, my effect is to deny. Now, I could also just do audit, just tell me so I can track compliance. And there's a whole bunch of these different effects. So deny would actually stop it happening, but I also might want to just audit. And generally, if we're starting off with a new policy, we'll start in audit so we can understand the effect it's going to have. If we just start in deny straight away and maybe we've misunderstood, we're going to have a really negative effect on people. So typically, yes, we're going to start off in the audit mode, understand what we're doing, and then we can do deny. But there's other ones as well. So there's things like, hey, deploy if not exists. So maybe it's an agent I want, and if that agent isn't there, well, then what I would actually do is run a template to go and install that agent. So they're really powerful capabilities. But that's one policy at a time. Very often, the result I want to do might be based on a huge number of different policies. So then we can have initiatives. So an initiative is just a set of policies. So here we can see one Azure creates, and it uses it for its Defender for Cloud. And it's a huge number of different policies. Again, if we look at definitions, we can see these are all initiatives. And we can see, for example, this one has 665 different policies in it. And the benefit here is twofold. So think about this for a second. By having that initiative, which is a whole set of policies, one, try and imagine assigning 665 policies. It would take forever. Well, with an initiative, I just can assign it collectively. But also to track compliance, rather than looking at the compliance of 665 different things, I look at the compliance of the initiative, which will show me the overall, hey, how compliant am I to that? So that's a really useful thing. And yes, I can track the compliance, and I can set it at management group levels, subscription, and of course, resource groups as well. Now, there's a Microsoft Cloud Security Benchmark, which is free. For the other initiatives and the regulatory compliance, I need the paid plan. And then that gives me a whole set of additional regulatory compliance options. So I would need the paid plan to be able to use things like that FedRAMP, HIPAA. There's a whole set of ISO ones. There's a lot of them there, but I would need the paid plan. The next thing is this role-based access control. So we talked about, again, assigning permissions at a certain scope. And really, Azure is made up of resource providers and resources, and there are actions that apply to the different types of resource. Well, I may not want, I almost never will, want to give someone, or ideally a group, we assign roles to groups and put users in the group so they don't get left behind. I don't want someone to have that permission on everything. Now, maybe it's my network team, and yes, they need permission on virtual networks at the entire structure. So I could give them the role at a fairly high management group level. But if I'm a subscription user, then my role might only be at the subscription level. Or maybe I'm working on only a particular component or service. Well, my role should be a particular resource group. And we always think least privilege. I give them the smallest set of permissions required at the smallest possible scope so they can get the job done. We don't give people extra. We'll hear things about privileged identity management where it's just in time. They can have maybe higher roles, but they don't get it all of the time. They have to go and elevate up, and then they get the role for that finite amount of time. And the way we think about role-based access control is, well, if I have all of these different possible scopes, the way role-based access control is going to work is I think about, well, there's a certain role, which remember, a role is a set of actions from the different resource providers. There's a certain identity, a user or group or service principal for a particular application. And what role-based access control is doing is this identity and this role is given at a certain scope, which again could be a management group, a sub, resource group, or even individual resource. And that is a role assignment. But always, 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 whenever you're doing this, always think least privilege. So at all times, the minimum amount of permissions at the smallest possible scope. So if I was to go and look at a resource group, I'll just pick anyone, it doesn't matter. I can look at access control. It will have a huge number of possible roles because it's a resource group. A resource group can contain any type of resource, so every possible role will be shown. If instead I looked at a certain type of object, so if I looked at here container registry and looked at access control, the roles available will be a lot less because it's a certain type of object. If I looked at a storage account, its access control will be less because, hey, it's only going to have roles that apply to a storage account. It's doing something with the storage resource provider. But if I was to look at a certain role, let's view this one, it shows me the exact permissions it has. So this is very small. I have read and write to the container registry. Now, there are some that are way more powerful. Owner is the ultimate. This can access any type, perform any action, change permissions on it for whatever scope it's set at. Contributor can do all of those things except change the permissions. Reader can read everything but can't change anything. So those are some core ones. And again, you want to be really careful. But if we looked at owner, for example, notice it's taken a while because it can do everything. It has 16,000 permissions because it can do anything. So just realize, hey, be careful of those things. You don't want to give more than you need to. And I can absolutely create custom roles. So if I was to add, actually not there, can't do the storage count. Let's go upper level. So I can add a custom role. Now I could also do this at a subscription or management group level. Now I could base this on an existing role. So I could clone an existing role. And then I could add and remove different roles and actions from it. So these are the permissions it has, but I could go and add a particular permission. I could exclude. So maybe it's a broader permission I'm giving it, like a wildcard, and then I want to remove a particular one, maybe write or delete. I wanted to remove. And I can say, well, where can I assign this to? What scope is valid to apply this to? And then I could go and give this custom role. So this is all about the idea of how can I give that least privilege? Maybe the built-in roles are too broad. I don't want to do that. So I'll create a custom role with just the specific actions it needs to be able to do its job. And again, this is inherited. So if I was to set this role assignment at management group 1, anything under it would have that role assigned. And you'll see this all the time. So if I was to look, let's say at just pick a storage account, doesn't really matter which one, but this one I use a lot. If I look at my role assignments, it will tell me, so this permission, for example, of owner, this was inherited from a management group, whereas this permission for contributor was inherited from its subscription. And if I keep looking down, so management group, subscription, and then some of them were set on this resource directly. So here I could see, well, Blob data owner, this was actually directly on this resource. So that's one I configured there. I've got one based on a managed identity for a virtual machine. Hey, that was set on this particular resource. So they get inherited, but I can be super granular where I need to be. Now, I should point out all of these roles I'm talking about are different from the Entra roles. So Entra has its own roles that apply for the tenant types of permissions. Now, some of these can impact our Azure subscription. Specifically, there's this idea of there's a user access control that I can do. So if I'm an administrator, I can boost myself up, and then any subscription that trusts it, I then get that particular permission. I don't know if that's showing on here, but I do have that capability. So right, you see this user access administrator from the root, because I've enabled that user access administrator permission for myself. So I can now, even if I wasn't granted anything at a subscription level, if I'm a global admin of the tenant that the subscription trusts, hey, I can give myself that permission and do the things I need to do. Now, another thing we might have is we think of roles as permissions I can have. We can also lock resources. Now, I can apply a lock at different levels. So I can apply locks when I think about, yes, subscription level, resource group level, and even resource level. And there's two types of lock. I can say cannot delete, which would make sense. It means you can't delete it. Or there's read only. So cannot delete means I could change it, I just can't delete it. Read only means I can't even write or modify it as well. But a huge point here is a lock only applies to the control plane of Azure. Because realize then underneath that you have the data plane. So if I was a database, well, hey, I create the database, I size the database, that's control plane. You're talking to the Azure control plane to do those things. But then to write a record to a table, if it's a storage account, to create a blob or delete a blob, that's talking to the data plane. That's not talking to the control plane. So when I use resource locks, I'm stopping doing something at the control plane. So I can't modify the Azure resource, but I can still do things, create, write, delete at the data plane. So I could write a record in a database. I could change a blob. I could create an image in something. So realize when I lock things, yes, I'm doing the lock and I'm restricting at the control plane. And of course, they get inherited down. But if we look at my locks, for example, I've got a backup protection lock. So the lock type is delete, so I can't delete it. But I can still delete things in the storage account. It's just saying, hey, you can't delete the storage account, but I can still absolutely go in within and delete blobs. So it's only impacting the control plane. So just a useful thing to know and understand. Okay, so now let's shift gears and let's talk about networking. Now, one of the key things to bear in mind when I think of networking is generally in Azure, we don't pay for ingress, so data coming into Azure from outside, but we do pay for egress, so data leaving our Azure set of data centers. So that's just a core point that carries on for everything. Now, if you're really into the deep networking, you should probably watch my AZ-104 Study Cram, because I go into a lot more networking detail here. But let's talk about the fundamentals of the networking. And I guess the most basic building block would be a virtual network. So I can think about a virtual network. I'll draw it quite big, so I'll put some other stuff in here. So we have the idea of our VNet. Now, interestingly enough, a virtual network lives within a particular subscription. So you can kind of think almost like a boundary here, and a particular region. So it lives within a sub and region. That's its boundary. It cannot span regions. It cannot span subscriptions. So this is the span of my particular virtual network, sub and region. Now for my virtual network, we'll call this VNet1. It's defined as one or more IPv4 CIDR ranges. So very common, we think the RFC 1918, the 10/8, the 172.16/12, the 192.168/16. It doesn't have to be. So I could bring my own private IP space or public that I've paid for outside of those, but realize they won't be able to talk to the internet directly. You still have to have some other mechanism to communicate, to actually be able to communicate to them from the internet. They're not just going to work and be internet routable. And then, optionally, I can have IPv6. And if I have an IPv6, I also have to have at least one IPv4. IPv6 subnet as well. And to that point, I'm going to break my VNet down into subnets. So I might think about subnet 1, 2, 3, 4, which will be a subset of the IP spaces available in the virtual network. Make sure you pick unique IP spaces, because I may want to connect networks together to my on-premises, to other virtual networks. If you use the same IP range, well, they won't be able to route. You'd have to have some kind of network address translation to facilitate that communication. So that would add a complexity to it. Also note, these subnets, I talked about availability zones. This is regional. So even if I'm using availability zones, I could have this one subnet could span AZ1, 2, and 3, and it just does. This is a regional resource. There's no restriction that, oh, a subnet lives within a particular AZ. It doesn't. I can have resources connected to all of the different things in all different AZs within that region. Now, each of these subnets, I will lose 5 IP addresses. So no matter what the size is, I'm always going to lose 5. So I'm always losing 5 because the .0 is the network address, which is just standard networking. In the same way, the last one, the 255. Now I'm assuming I'm doing /24 here, but whatever the last and whatever the first is, the last one is the broadcast. So I lose that. That's just standard. Again, I can't give that to a resource. The one after that, the .1 in this case, will be the gateway, the Azure Gateway resource. And then the .2 and .3, these are used for DNS purposes. So we're always going to lose 5 from any subnet we create. So just when I think of sizing, realize, hey, there's a certain amount we always lose. And again, these are private IP spaces. So if I create a resource in here, and again, the resource doesn't actually live in the subnet. The resource is somewhere else and it has a virtual NIC, and that virtual NIC is attached to a certain subnet in a particular VNet. But what this is going to get is a private IP allocated from the IP range of the subnet. Now, it's using DHCP, but so you can't run your own DHCP server in here. The Azure Fabric will allocate an IP address. Now, one of the things I can do is if I needed it to always be the same IP address, you can do from the Azure Fabric, I can say, hey, this resource should always be given this IP addresses. But this is a private IP space. This is not accessible from the public internet. I would have to do something to enable it to be communicated to from the internet. Now, one option, and this is ugly and we wouldn't want to do this, but let's just draw them out. One option is, hey, I can create a public IP. And what I can do is I can associate it with the network configuration of the resource. And a public IP, if we just go and look at public IPs, we can create a prefix with a contiguous block. If I create a new one, we always want to use standard today. And it still gives me the option, but we want to use the standard. I think they may even have a warning that basic's going away at a certain point. But we want to use a standard SKU. With standard, it will always be static. It won't change if I stop using it. Now, if I do basic, it can be dynamic. But again, oh, there we go, it's telling us. 30th September 2025, basic public IP will be retired. So I wouldn't be using it. You want to move away from that. So you want to be using standard. And it can be IPv4, IPv6. And it can be regional or global. So global can be used for global anycast services to utilize. And then, hey, I can now just leverage this for one of my resources. So I have to go and create a public IP. Now, you also saw it had the idea of, further up here, was prefixes. So I could get a contiguous block of IP addresses. Now, recently, they have changed that you can bring your own IP addresses. That is a whole set of processes that has to go into that, and I'll talk a bit more about that. But you can bring your own prefix to Azure now. It has to be, I think, between a /21 and a /24. If it's IPv6, it has to be a /48. So that's your range that you use and own. You want to leverage that in Azure. There's a set of processes you have to validate, prove you own it. You have to provision it. You have to make it available and assign it to a resource. Then you have to commission it. So it's advertised out to the internet. So there's a whole set of processes. But technically, yes, now you could bring your own public IP range to Azure. But most people will not. I said this is yucky because when I assign it directly to a resource, very often if we're talking about things in the internet, we want to make it highly available. So I probably want, instead of this, I'd want to use a standard load balancer. And then people talk to the standard load balancer, which has a back-end set to make that service resilient. I could use a NAT gateway. So the whole point of NAT gateway is with NAT gateway, it's very efficient with my ports for the SNAT, because I have to do network address translation from the source. And I can associate that with a subnet level, and then I can get external egress to the internet through that. I could route via Azure Firewall. I could have, that external standard load balancer could give me egress out as well if I add outbound rules. But the default implicit internet access that is there today but is going away is going away. So if I want resources to be able to talk to the internet going forwards, I have to do something explicit. I have to give them a public IP. I have to associate a NAT gateway to its subnet. I have to have a network virtual appliance or Azure Firewall with user-defined routes to tell it to use that for egress. Or if it's behind a standard load balancer, I have to have outbound rules. So I have different options to do it. But that implicit, just default where Azure takes care, that is going away. I have to do some explicit access to that. As I mentioned, this is DHCP, but I can specify specific resources if I need to always get the same IP as part of the configuration of the resource. Now, as I talked about, this virtual network is bound to a particular region and it's bound to a particular subscription. Well, what about if I'm using another region? What about if I have other subscriptions? I don't want, if they're using each other's resources, to have to go and talk via some public endpoint. So what happens if, hey, I've got another virtual network over here. So I've got VNet 2. And maybe I've also got a VNet 3. And I want the resources to be able to communicate using these private IP addresses. Well, what I can do is I can peer them. And this can be within the region, this can be inter-region. So I could add peerings here. Now imagine this was our hub. So imagine, for example, this virtual network had our gateway. Now this gateway could be for a site-to-site VPN to connect on premises, could be ExpressRoute. We're going to talk about these. And these are spokes, and these spokes want to be able to use the gateway, the connectivity, and be told about the routes that this knows. What I can say is on this end of the peering relationship, I can say allow gateway transit. And on this end, I'll tell it to use remote gateway. And what that will do is when I have those things, this will now be allowed to route traffic to these from its gateways. And it will also, using BGP, Borderless Gateway Protocol, the routes it knows about through the IP space that the gateway talks to, it will tell this VNet. So the VNet knows, oh, if I want to get to whatever other IP spaces on the other end of this gateway, I'll send it across this link. And if we look, they did change the terminology. So it doesn't actually say allow gateway transit anymore. They changed the term, but it is the same thing behind the scenes. If we look at my peerings, so I can see I've got 2 connected. And if I look at it, it would be this, allow gateway in the hub to forward to, so that's allow gateway transit. And then on the spoke, I would do this one. Allow to use the remote gateway. So that's obviously the wrong way around. So I would actually go to the spoke network, its peerings, it has a peering to the hub. And so I would enable the spoke to use the hub's remote gateway. So those two things together will now enable it to use the hub's actual connectivity. Now, one really important point when I think about these relationships, these peerings, so I've got these spokes, and these spokes are talking to the hub. It's not transitive. These can't talk. I would have to go and add specifically peerings between VNet 2 and VNet 3. Or what I could do is if I had something like Azure Firewall, so let's say, for example, I put Azure Firewall, or it could be some other network virtual appliance, I could tell VNet 2, hey, if you want to get to the IP space of VNet 3, send it to the Azure Firewall, and then it could go and send it. So I could enable them to be transitive if I actually went and used something like Azure Firewall or another NVA and told it, hey, from your IP routing, so I'd have to have user-defined routes. So I'd have a UDR, hey, to get to here, your next hop would be over here. So the whole point is it would be lots of user-defined routes to say, hey, go here, and then it could go and forward it back. When I think of that connectivity, yes, I can manually go and create the peers, manage the peers, and try and view the topology of the peers. But there is actually another solution. So what we have is something called Azure Virtual Network Manager. And it does a number of things. What I'm going to focus on here in this instance is configuration. And what I can do is I can create network groups. So I create these network groups, and this could be static or dynamic. So I could manually put virtual networks into a group, or I could create rules with dynamic that based on certain criteria, they get added into this network group. A VNet can be part of multiple groups. And then what I can do is I can define a configuration of connectivity. And that configuration could be the hub and spoke, i.e., okay, there's my main VNet with the gateway, and then I have a bunch of spokes hanging off of it. Or I could say I want mesh. And obviously in a mesh, everything just talks to everything. And it doesn't use traditional peerings. It does this other clever stuff. And I've got a whole video on Azure Virtual Network Manager, so go and check that if you want to learn more. But it's doing its own thing. And then within that region, it just gives an any-to-any connectivity. So that's one part of its functionality. And it has a great ability to view them and now centrally manage them. This is really powerful compared to trying to manually create all the peerings. Now, the other thing it does is I can create this idea, that's a bit more space, of security admin rules. And now think about, you've got just the traffic coming in. Now this is going to apply before any local virtual network, subnet level or NIC level rules. And what I can say is, sure, I can set it to allow. So if I say allow this type of traffic, it's going to flow through to the network level things I can do, i.e., it will apply the next thing, which is network security groups, which we're about to talk about. But I can also say always allow. This bypasses the NSG and goes straight to the target. So even if a local NSG tried to block the traffic, it couldn't. Think of this as a funnel. It goes through here first, and then allow would then hit the NSG. Always allow says, I don't care what the NSG wants. I'm going to let the traffic through. Now that would be really useful. Consider I had maybe domain controller connectivity. Maybe I had certain resources that we had to use for maintenance patching. I don't want to risk some local admin or app owner who doesn't 100% understand the implications of rules they might create. I don't want them to be able to block it. I always want to let that through. So I can do that with this. And of course, I can also do deny. If I say deny, it just kills it. It won't even ever get to the NSG. So this Azure Virtual Network Manager and these security admin rules are really nice for that set of capability. Now, speaking of network security groups. So I drew this idea of, oh, okay, well, it goes to the NSG. So let's talk a little bit about these NSGs. So an NSG is fundamentally a set of rules. Now, these rules are based on a number of different attributes, but I have a priority for the rule. I have a name for the rule. I have a source. I have a destination. And we have ports. And we have an action. Allow, deny. Now, these source and destinations are interesting because we'd obviously think that I can do these based on IP addresses. So yes, I can do it based on IP. But maybe I want to control access to Azure services. Now, Azure services have a huge range of IP addresses. They can change. Maybe I want to access any Azure service, maybe only those in a certain region. That would be impossible for me to try and maintain all of the IP addresses that are the public endpoints that service could be available via. And so we also have this concept of a service tag. Now, they won't always be available for source and destination. It depends which direction this rule is applying to. I also have the ability to have application security groups. And really, this is just a tag that we put on the NIC. Let's look at one of these. So if we jump over, so let's just look at network security group. And we'll just create a new one. So we would pick a resource group. Now it has to be in the region of the VNet I want to create it in. So that's an important point. The region has to match where I'm going to use it from. And then once we create one, let's just go and pick a really basic one. You can see we have inbound rules and we have outbound rules. Now you'll notice it has these very low priority. The lower the number, i.e. 1 is the smallest number, is the highest priority. So 1 is best, 65,500 is basically the worst. So it has default rules for outbound and inbound. So the default rules is basically saying, look, anything from the virtual network can talk to anything in the virtual network. Anything going out to the internet is allowed. Anything else is denied. For the inbound rules, I've added one. So you can see it's got a lower priority. I did it for port 80. So TCP port 80 inbound into the virtual network, I'm actually blocking. But virtual network to the virtual network, I'm allowing. The Azure load balancer, I'm allowing. Anything else is denied. And you can hide those default rules to just see the ones you have created. But if I go and add a rule, so notice I could do an IP address. I could do a service tag or an application security group. So if I pick service tag, it has ones for internet. So internet is any IP space that isn't the known virtual network. Now the known virtual network could be the virtual networks, but also anything it's peered to. Any known space it has, that's considered virtual network. And then you can see there's Azure Load Balancer. It has to be able to talk, probe, etc. Then, hey, there's lots for API management per region or global, app service, global, and then ones per region. So I can be super specific about what I want to allow. So that's the source. And then the destination, hey, where is that going to? Service tag or sets of IP addresses, could be IPs or CIDR ranges. I can do a custom service, so I can pick the port, I can pick the protocol, and I can allow or deny. Then I set the priority and the name. Now, the whole idea of this application security group, it's just a tag. And it's just a value that I configure on a network interface. So I could think about, if we just search for them, application security groups. So I've created a few. And again, you'll only see the ones in the same region as the NSG. And all I would do here is my virtual machine, look at its network settings. But here you can see my application security groups. And if I hit configure, I can just add one of the available application security groups that is in my region to it. And the benefit here, if you think about it, is what we're going to do is these network security groups we create, we are going to associate. So I'm going to say, hey, this NSG here Well, I'm going to associate it to that subnet. So we do this association. And they're all, if they were just based on IP addresses, it means, hey, everything of a certain type. Maybe it's a SQL database I want to create a rule for, or web front ends. I'd have to have very contiguous sets of IP spaces, or it gets really messy. If I use the application security group, I could just tag the network configuration of all my SQL databases as your SQL database, all my web front ends as web front ends, and then my rules can just say, hey, web front ends are allowed to talk on port 1433 to SQL databases, and I'm done. So now I'm not worried about, well, which IP address are they actually using? It makes it more flexible for me to actually be able to use. So that's why the application security groups are there. It's a really useful capability. And if I'm ever curious about what rules a resource is seeing, if we were to go and look, for example, at my virtual machine for a second. So here I can see the inbound port rules that are applying to it right here. But if I look at my network, I can see my IP addresses, and notice what I have down here is effective routes. So these are the routes that my NIC is getting from, hey, the virtual network it belongs to. So this is where, hey, if I'm peered, I would know about my peered if I had user-defined routes that said, go and talk to this Azure Firewall. But you can see all of the different ones I have that are impacting this particular NIC. Now, I did mention Azure Firewall. So Azure Firewall is a first-party Microsoft network virtual appliance. And what I can do with Azure Firewall is define rules. So I can think about having rules this could be for inbound and outbound. So it can perform outbound SNAT, but it can also perform inbound. So it can do DNAT. I can do rules at layer 4, so TCP, UDP. So I can have network layer rules. So it's layer 4. And I can do application level rules. So layer 7. Now the exact features vary by SKU. So if we go and look at the different SKUs that are available, we see there are quite a few now. So we have this idea of basic, standard, and premium. And as you can see, like basic has pretty low performance, whereas standard could go up to 30 gigabits per second, premium up to 100. But then from a feature perspective, so standard and premium can do filtering based on categories. It can act as a DNS proxy. And then if you go to the premium, it also can do inbound and outbound TLS termination. It's a fully managed intrusion detection prevention system. It can do URL filtering. So it can do SSL termination to then go and look at the actual path that is part of the URL. So there's different sets of functionalities based on the exact functionality you require. And what I would do is once I've created my instance, well, then we have to use user-defined routes to send traffic to it from different places on our network. So that's the goal of what we're doing there. The next thing I wanted to talk about was actually Azure DNS. So we as humans are terrible with IP addresses. We can't remember IP addresses. And so we need DNS to have a friendly name for a particular resource that we can go and leverage. And Azure DNS has both public and private DNS capabilities. So if I think about, I should have a color. So we do Azure DNS. So from a public perspective, so a public zone would be, hey, on the internet, we're going to go and look at these different types of record. And I can create particular types of records, like host records and CNAME records. I think there's MX records. But I can also do something called an alias. very often we'll create a record that actually points to an Azure resource. And imagine we use this an alias or CNAME referencing the service, and then we deleted that service. But we'd still have this pointing now to a resource that doesn't exist. This is called dangling DNS. And a bad guy could notice we have this dangling DNS and go and create a service with that name. So now a record in our public trusted zone is pointing to a bad guy's service. So what alias does is you actually tell it to create the record but point to an Azure resource. And so if I then went and deleted, Entra. Nope, let's go over to Azure. So if I was in DNS, my DNS owns, and I went and created a new record, so I can create a record set, and it could just be, again, all these different types of record are available to us. But what I could also do is I could say, yes, it's an alias record set. Now it will limit the types of record I can create. Like, I don't think I could write MX, I can't do alias, but I can absolutely do this. And I'm going to point to a specific resource. And so the point now is if I deleted that resource that this record pointed to, then that record will become an empty set. So a bad guy can't go and try and hijack that from me anymore. It would be unusable to them. So that's a really useful thing. Now, there is Azure Traffic Manager as well, remember, which creates public DNS records. But normally I wouldn't point to that directly. I would actually use a DNS record in my vanity, my custom domain, to point to that. So that's the key goal around that. Then we have the idea of private. So these records are accessible from the internet. Then I have the idea of private, where I'll create my private zone. And once again, I can create different types of record in here. Now, I can once again manually create records, but I can also have automatic. And what automatic will do is I'm creating this private DNS zone. And again, we have all the different types of record, A and C name, service, text, list goes on. But what I can do is, yes, I could manually go and add entries. But also, I'm going to associate this to virtual networks. So I can associate for two different purposes. So I can associate something called auto registration. Now, a virtual network can only auto registrate to one private DNS zone. And a particular private DNS zone can be used by up to 100 virtual networks for that registration purpose. So I can have 100 different VNets registering records to this zone. I also can configure it for resolution. Looking stuff up. And a virtual network can actually connect to up to 1,000 different private DNS zones to look up records. And a particular zone can be used by 1,000 virtual networks for resolution purposes. So that would mean, hey, I create a resource with a certain name. If it's configured to auto-register to this private zone, it will go and create the record in that to go and leverage the different lookups. So that's a really powerful capability to have name resolution between my different services. Now, when I think about these private DNS zones, for example, when I create a resource, how does it go and use Azure's DNS? Well, Azure's DNS is accessible on 168.63.129.16, always. So Azure resources will talk to that IP to look up Azure DNS, which also can go and resolve to internet things, but then it would be able to go and tie it into these records. Now, this IP address is only accessible to resources in a virtual network. if I wanted to use this from on-premises, for example, then I would need a resolver running in here. Now I could manually create a resource that it could talk to that would then go and talk to this, or Azure now has the Azure Private DNS resolver that is a target for things outside the VNet to talk to, which that private DNS resolver can then resolve records in these private DNS zones. But also the Azure Private DNS resolver can be configured for things that are using Azure DNS. It can go and forward to custom DNS servers for my own zones. So the Azure Private DNS resolver is really powerful to enable both of those particular sets of capabilities. There is a default DNS zone for each VNet that's just there. You can't manually add records to it, but by default, you'll see this .internal.cloudapp.net for your resources, where I'm not doing this kind of auto registration. These are global, so I can attach these to VNets anywhere in the world, if with the right permissions, even any subscription, even any tenants. I just have to have the permission to go and link to it. And of course, I can use custom as well. So I absolutely can, at my VNet level, I can tell it which DNS servers I want it to configure as part of that DHCP when I create resources, what it wants to point to. Now, if you're using custom, make sure, well, does it still need to be able to resolve to this as well? Do I need to put forwarding in place or some mechanism to allow that to work, to ensure, especially if I'm using private link and automatic registration of those, I can still go and resolve to this successfully as well. So that's an important thing to consider. But hey, this ability to auto-registrate and have these private zones, super powerful. And you may have split-brain DNS. You may have some things published to the internet, which will be in a public Azure DNS zone. And then maybe I want a different resolution internally. Well, that would then obviously just be a private DNS zone. So I have both of those options available to me. Now, I talked about internet egress and the fact that, hey, by default, the default internet egress is going away, and we're going to have an explicit way to talk to it, NAT gateway, behind a standalone balance with outbound rules, Azure Firewall, whatever that is. But what about if I want to talk to private resources? So to give myself a bit more space, and let's draw a VNet again. Slightly smaller this time. So I have my virtual network. And we'll just do a particular subnet here. This is going to be my gateway subnet, because I want to be able to talk to other private things. Minimum is a /29. The recommendation nowadays is a /27. So I could have coexistence with things like a site-site VPN and an ExpressRoute. And if we start off with VPN, there are two types. There's both a policy-based, which is static routing. It's really not recommended. So if I do the policy, so let's say we have a VPN gateway. Yes, I can do policy. But if I do policy, it's one tunnel. And it's super restrictive on what I can do. It's not common with today's gateways. I think it's considered legacy. It's only using the basic SKU. I think I have to use PowerShell or the Azure CLI to create it. Generally, we are not going to use that. What we're typically going to use is the route-based or dynamic routing. So if I do route-based, I can have n number of tunnels. And also one of the really nice things it has is point-to-site VPN. So I can have an individual computer. It wants to go and connect to the VPN gateway so it can have connectivity. The only reason I'd ever use policy is if the VPN client I have on premise wasn't very good, my VPN server, and it had to use that. But we just wouldn't really want to do that. And so my goal here would be, if I think I have my on-premises network, I am over the internet. I have my own VPN server, and I'm establishing now that private IP space to IP space. Now, there are different models for this. On the Azure side, typically you're going to have this idea of an active and a passive, but you can do active-active. And so on the customer side, it might be, hey, it kind of just normally does this conversation, or I could absolutely set it up so that the customer maybe has redundant gateways, and this could actually be active, and you could also have kind of combinations of those. You can make it resilient. So you do have a lot of flexibility in how resilient you want that configuration to be. But this is super common, site-to-site VPN, connecting this IP space to this IP space, and it's known, if remember those peerings, use remote gateway, I can do those things. It's going over the internet. Some people don't like that. It's encrypted. Latency may vary because I'm going over the internet. So my other option for private connectivity is ExpressRoute. So if we think about Microsoft has this huge global network. So you have this Microsoft backbone, the WAN. And all of its regions are connected to it using these resilient, redundant regional network gateways. And Microsoft extends their network at certain points of presence or meet-me's around the world. So you'll hear them called peering points, meet-me's, they're carrier hotels, they're neutral facilities where different networks come together and connect. So if we call these peering point. And what I can do as the customer is I can extend my network. Now, I'm probably going to use a carrier to do this, but maybe I've got multiple locations. I might have an MPLS. I might have a direct connectivity. But ultimately, I'm going to extend my network into this as well. And then within that location, there is a cross-connect. And now I have, via an ExpressRoute circuit, my network is connected to the Microsoft backbone. Then I have an ExpressRoute gateway. And what this is now going to facilitate is private peering. So it's a particular type of connectivity. So now what I can turn on is private peering. Which again is this IP space connected to this IP space. And I can have multiple networks. So I could also kind of connect up through here. That could work as well and have its cross connect. That would be a different circuit because it's different meet-me, different circuit. But this gateway could connect to both of them. So this could maybe have a different weighting. I could use path prepending to make it less desirable. But if this was down, I could go and use this as a backup route. So ExpressRoute private peering lets me connect private IP spaces to my virtual network and its known connected spaces. Now, one point on this, my on-premise network probably has its own connectivity between them. But maybe I want a backup route to be able to route via the Azure backbone. So one of the things I can turn on is something called ExpressRoute Global Reach. What that now enables me to do is over the Microsoft backbone, connect my networks together. That's all Global Reach is. It's using the Microsoft backbone. It will route between your different ExpressRoute circuits to your different locations to enable me to have connectivity between my locations. So it's different. So the private peering is about, hey, my IP space talking to the IP space within my particular virtual network and its peers. Global reach is I want my locations to talk to each other using the Microsoft backbone and those ExpressRoute circuits I have created. So that's the goal of this. I can coexist with site-to-site VPN. So either I have a backup ExpressRoute in case there was a problem at this particular meet-me location, again, natural disasters, cold weather we've had. So I could have a second one at a meet-me, again, long distance away, or I could use site-to-site VPN as my backup path. I can choose whatever one I want to do there. Pricing is based on the circuit. There's premium. Premium lets me connect to regions outside my geopolitical boundary. It lets me use Microsoft 365 services over it. It lets me have more routes advertised. If I have a very large, complex network, that may be required. I can also, I guess I should point this out. So I talked about a virtual network. We'll realize there's also a whole bunch of Azure kind of PaaS services. And one of the things I might want to do is I want to talk to the PaaS services, but not going through a VNet and private endpoints. I just want to be able to talk to like my storage accounts or a database using a private connectivity. And so what we can do here is we have something called Microsoft peering. So Microsoft peering, if I enable this on my circuit, what I have is, if you think about this BGP to advertise routes, I create a route filter which says which services do I want to advertise to on-prem to come through this connection. And then, well, it would talk through their ExpressRoute circuit to talk to those various PaaS services that I've advertised and enabled through that route filter. So there we go. This may seem like it's getting pretty complicated. Okay, so I'm creating gateways, I'm creating my hub networks for the connectivity to on-prem and between other networks. Wow, can't someone else do it? And so that idea of can't someone else do it is what Azure Virtual WAN is. You may hear about Virtual WAN. And Virtual WAN is exactly this idea. Now there's two SKUs, there's basic and standard. For the basic SKU, it's really about site-to-site VPN only. So that I get with basic. But if I then think about the standard SKU, well, the standard SKU, yes, does site-to-site VPN, but then it also does ExpressRoute. It also has this idea of, hey, you have your own VNets, and I want them to have that transitive communication. It does that. I could also think about, well, I have other virtual WANs. Typically, my virtual WAN is going to be this regional construct. Hey, I want to be able to connect to other virtual WANs. So standard is going to let me do those things. So that is probably something, if I'm in a richer environment, I'm going to want to do that. And if we look at the documentation, it says exactly this. So, hey, basic is site-to-site only, standard, ExpressRoute, user point-to-site, site-to-site, intra-hub, VNet to VNet, transitive. I can have a secured Azure VWAN. It puts Azure Firewall. I can deploy my own network virtual appliances into the virtual WAN. So standard is obviously the typical one most will use, but if I'm in a really basic environment, well then, hey, maybe I don't need that. I can just use the basic. And obviously it's going to be cheaper. And that's really the key point around a lot of these things is Azure is consumption-based. I'm going to pay for what I need to use, so I can leverage that. We've mentioned this a few times, and it is about kind of the routing, and we drew this over here. User-defined routes. So there's a default set of routes that a virtual network will learn based on its gateways, based on maybe I've got Azure Route Server, which can then go and talk to my own network virtual appliances to learn the IP space it can connect to. But I can also, with user-defined routes, override those default routing policies. And all the UDR lets me do is I say, hey, for this IP space, your next hop should be this type of service and this particular IP address. So it's just a way to override the default routing that I'm going to get. So that's our goal. So we're actually going to use user-defined routes if I want to modify how traffic's going to flow. Hey, I need to send my traffic to Azure Firewall. I'm going to create a UDR. I'm going to link it to the subnet, which will say, hey, the next hop for this target IP space is this virtual appliance, and it's the private IP address of my Azure Firewall. So this has a private IP. That would be the target of my user-defined route. The next thing I want to talk about is when I think about protecting communication to, I did this idea of Azure PaaS service, but imagine the idea that, okay, I do have, for example, a storage account. So network security groups are fantastic for controlling communication to and from things in the virtual network. But what about if I want to protect my PaaS service on what can talk to it? So they have their own little firewalls. So there's this idea that in front of my service, it has a firewall. And if I want to be able to say, well, look, this particular VNet here, this subnet, so subnet 3, I want it to be able to talk to the storage account. The problem is, this is a public endpoint. This is not living in my virtual network. It doesn't have a private IP address. This is just exposed really out to the internet with this public endpoint. So there's some public endpoint here. This is all private IP space. So how do I say, hey, look, a resource in this subnet is allowed to talk to this? So what we can do is we can create something called service endpoints. So what we're going to do is we add a service endpoint, I should get rid, for a particular type of service to the subnet. What that now does is it makes this subnet a known entity to resources of the type I add the service endpoint for. So what that now lets me do is, hey, if this is VNet 1 and this is subnet 3, now the rules on this service, I can say, hey, I'm going to allow in VNet 1 subnet 3. And it also establishes a more direct communication path between them, because in the log, I'll actually see the private IP space is trying to talk to me. So service endpoints are all about, hey, I'm going to enable a particular set of resources in this subnet. It wouldn't apply to other things in different subnets. It's only in this subnet to be able to be allowed to talk to a service. So if I was to go and look at a virtual network quickly, if I look at my infra subnet, I can go and enable it for particular service endpoints. So now these types of service would see this particular subnet. So I think I've actually got it on this subnet. Let's have a look at this infra. I've got too many virtual networks in this environment. But I could just light this up for any of these. And then once I do that, and I could just check that for really any one of them. If I then looked at my storage account, and I just pick a storage account, it has its concept of networking. So I'm over here. And it will actually enable me to go and add the service endpoint anyway, for even if it doesn't have it. Now, right now it's enabled for anything, but if I enable it for selected virtual networks, now what I could say is add an existing virtual network. I can select a virtual network that I have here. And then I could pick a particular subnet. Oh, it's service lockdown, that's the one. Notice this one is not telling me I need the service endpoint required. It's there already, but it's now visible to me. These ones, it would have to go and add the service endpoint to the particular subnet. But now I could allow through only particular subnets. So that's what a service endpoint does. A service endpoint is all about me saying, hey, I want to let through things only in this subnet. So even though it's a public endpoint, I want to be able to say, hey, only these things are allowed to talk to it. So great, that is what this functionality is lining up. It's still a public endpoint. It's going to let me leverage it. There's another level I can take this to. We have something called private endpoints. Now, a private endpoint, I'm just going to draw a different resource just for simplicity. And so now let's say I've got storage account 2. Maybe I don't really want that public endpoint open to anything. So what I can do with private endpoints, it creates an IP address in the subnet. That private endpoint talks to a particular instance of the service. So it's not talking to the public endpoint. The public endpoint can be completely shut off. It's only using this private endpoint. Now, I do also require some special DNS. So I'd probably create an Azure Private DNS zone because it still has to be able to use the name, but there's going to be a private link version of it. So there'll be records added that now says, well, to talk to storage account 2, it actually resolves to this IP address. But it's the proper name, so the TLS checks on the certificate will still work correctly. So private endpoint, it's an IP address in my subnet. It just gets allocated out of my subnet that points to a particular instance of a service. Now, I may also have my own services. Consider maybe I've got my own virtual network over here. And I've got some resources. And they're sitting behind a standard load balancer. So it has a front-end IP address, which is private. And I want things in here or anything connected to it, because these are just IP addresses. So the benefit of a private endpoint is whereas a service endpoint could only be used by things in its subnet, this is an IP address. So I could talk to this from other things in different subnets. I could talk to it from peered VNets. I could talk to it to on-prem. It's just an IP. I just have to make sure this DNS resolves consistently wherever I'm trying to use it from, so the name resolves to this IP instead of the public endpoint. Otherwise, the TLS will fail. I won't be able to talk to it. But I've got my own custom service now. I don't want to peer them, because peering them would solve the problem, because now this IP address will be routable. Maybe they're overlapping IP address ranges. I can't peer them. Maybe I don't want to peer them. Maybe I'm providing a service, but I just want them to access this one IP address. So what I can add the private link service to my standard load balancer. And now I can create private endpoints that talk to this. And it's going to do NATing, network address translation, for these things. So I can also expose my own services. If I'm using a standard load balancer and I put private link service with it, then I can go and talk to that front end without having to peer the virtual networks. So that's another way to secure and enable those communications. Another connectivity service I guess I should mention quickly is I've talked about VMs a few times now. Well, I made a whole big point that giving a public IP address directly to the VM is ugly. I don't want to do that. It's risky, horrible. So then how do I talk to my VMs? Well, ideally, these private IP addresses I talk to, because I've got site-to-site VPN, I've got ExpressRoute, I can just talk to the private IP address of my resource. But what if I can't? So what I can deploy as a service is something called Azure Bastion. So Azure Bastion enables me to talk, for example, from the internet, and think of it as a managed jump box. So I'm going to talk to this, and then from here, I can go and communicate to my virtual machines. I can do SSH, I can do RDP. It's integrating with Entra, so I could have things like conditional access policies to, hey, you have to have done a strong authentication before you're allowed to go and talk to this service. So it's really powerful here. It's going to deploy into its own Azure Bastion subnets. This is called Azure Bastion subnet. It's a /26 in size. But now it's just a managed jump box for me. And there's different SKUs available for this. And really the SKUs divide the functionality. There's a basic developer SKU, so it's only a VM in the same VNet. If I go to basic and standard, then I can talk to VMs in peered VNets. If I go standard SKU, I can use RDP to Linux and SSH to Windows, so I can do kind of a cross-platform thing. Standard also lets me use the Azure CLI to connect to not the portal. It has better scaling. I can have a shareable link. I can disable things like copy paste for the web clients. So ordinarily, I will just go in the portal and do connect. But with the standard SKU, I can just use an AZ CLI command to do that connection. So we have different SKUs available depending on the exact functionality I require. Okay, so I mentioned load balancing and behind a standard load balancer. So let's talk about that because it's super important when I think of any service and wanting my service to be available. And there are two levels when I think about load balancing, because I can think about there's the idea of a global level where I want one endpoint that I can go and talk to that's going to work no matter where my resources are. And then I can think, well, obviously we have our regional level balancing. High availability, I've got different instances within a region, one endpoint to those for high availability. And then I have deployments around the different regions that I want one global endpoint that is used by the client. And we need both of these things. And when you think about, there's really two layers I can apply these solutions to, depending on the type of service we're offering. Now, if I am a web-based solution, so I'm talking at layer 7, I'm thinking HTTP, S2, WebSockets, etc. Our solution is Azure App Gateway. So it's layer 7 solution that understands HTTP, HTTPS. And then we have a more basic is the right word. Then we can have the concept of a layer 4. So a layer 4, so this would be TCP. This would be UDP. So this is the Azure Load Balancer. Now, for the Azure Load Balancer, we'll actually start here. There are two different SKUs available for this. Both of them are doing the same thing. We have the idea that we have our Azure Load Balancer instance, and it's going to have a front-end IP address. Now, this can either be internal or external. It's one or the other. It's an internal load balancer or it's an external load balancer. And then what I'm going to have are one or more backend pools. So I can have a backend pool 1. I can have backend pool 2. Because I can have different IP addresses using this, that it's going to go and balance the traffic between. There are health probes that I configure that will be used to go and check what are the instances in the backend pool there and responding and available to us. And what I do is I create rules. Now, the rules are really based on the idea that, well, the pool I'm going to use and then the number of tuples I want. So I can have this idea of 5, 3, or 2 tuples. What does that mean? Destination IP, source IP, destination port, source port, protocol. That's 5 tuple. So I could use 5 tuple for my rule, which would mean super specific. I have to have all of those things matching to be sent to the same backend set member. If I do 3 tuple, I take out the port. Now I'm only caring about the destination source IP and the protocol. 2 tuple says I don't even care about the protocol. The source and the destination IP match, send it to the same backend set. So it's how sticky I want to be from a particular client to always go to the same backend set member. So that's why we have those different tuples. And so we can have these rules to define, hey, coming in, where does it go to? We can have NAT rules to go to particular sets. I can have outbound for the standard load balancer, which is a great point. So we do have 2 different types. So we have free. I'm going to do it in red. Now, free only supports 300, I think, in a backend set in kind of availability set configurations. There's no SLA, but it's going away. I think it's the 30th of September 2025. It's rest in peace. It's gone. Same as the basic IP address. Public IP is going away on that same date. They're basically killing these off. And so this is generally not something we're going to want to use. What we're going to use is the standard. So the standard can be 1,000. It has to be in the same VNet. So this is not spanning virtual networks. The load balancer is in a particular virtual network. The backend members have to be in the same virtual network, but it supports availability zones. Obviously, it's got an SLA because it's a paid for resource. And this is primarily what you're going to use. If it's an external, it's going to use a standard public IP. It's locked down by default. I have to add outbound rules to be able to go and talk to the internet. And the backend pools, what's really nice about this in standard is, yes, they can be NICs or they can be IP addresses. Whereas with the free, it's only NICs, which can restrict from some of the newer types of service where it's more useful to be able to base it on the IP address. But either way, has to be in the same virtual network, the resources as the load balancer itself. And again, if it's external, the public IP has to match the SKU of the load balancer. So a standard has to talk to a standard public IP. A free has to go and talk to the free public IP addresses. That IP address, if I'm using AKS, then the pods don't have their own NIC. They have an IP address. So now I could have pods as part of that backend set. The health probe is going to use that HTTP, standard adds HTTPS checks to it, TCP, and those load balancing rules bring all of that together. There is something called a floating IP. If I have a floating IP rule, then when it gets sent to the backend pool member, the IP address that is sent to it is the front end IP. It doesn't translate it to its IP address, the actual resource. What that resource will see is what the front end IP address was. And that's going to be useful to avoid that rewriting for a number of use cases as part of the communications. So floating IP is doing that. It's going to see this IP instead of its own IP being sent to it. So layer 4, within a region, I'm going to use standard load balancer. Fantastic. Okay, but if it's a web-based solution, I don't want to use this because I'd rather have richer functionality. So that's where I use the App Gateway. Now, from a structure perspective, once again, it has a front-end IP. Now, what has recently changed? So before, it had to always have a public IP. In preview, at time of recording, you can now turn off the public IP. And optionally, it can have private IP. So at this time, both of them are now optional. I have to have one of them, obviously. But before, we always used to have a public. We could use NSG rules to make it unusable, but it had to have it. But now they do have the option of removing that. And this is absolutely focused on HTTP, HTTPS, HTTP2, WebSocket type communications. It's at that layer 7. There's basic and standard SKUs. There's a V2 SKU. The V2 SKU adds auto scale based on load, zone redundancy, or it can be zonal. But it still lives within a specific region. Now, the backend targets, you have a lot more flexibility, but it itself is within a particular region. Now, it deploys into a subnet. You can pick which subnet. It doesn't have to be a special name, but it deploys into a subnet. A /24 is recommended for growth. If it was the V1, only supports 32 instances, so you could use a /26. Optionally, one of the nice things that I can do is you can add the web application firewall. So what that adds is protection from a whole set of, it's the Open Web Application Security Project. It's a common set of vulnerabilities that people might try and use to compromise your web-based app. I pay for it, but I can add it to my App Gateway instance and it will add protection for those. But the whole point here is it understands the application. I can do URL-based routing and redirection. So I could do a HTTP to HTTPS, for example. I can rewrite the URL. I can rewrite things in the request header. I can do SSL TLS termination. I can offload that termination to the gateway and take it off of my backend members. I can do session, i.e. cookie-based affinity. So there's a whole set of capabilities there. It can be dual stack, so it can be IPv4 and IPv6. But what we're going to create from a structure perspective is we have a listener. Am I in the right color? Nope. So we have the front end IP. We're going to have a listener. Now this listener is basically listening on a certain port. So I create the listener to listen on a certain port on that front end configuration. Now from here, I can have a basic type listener. So all the basic is basically saying everything on that listener is going to a particular rule. Or I can have multi-site. And what a multi-site listener does is I can have multiple listeners on the same port, and I can, based on the fully qualified domain name that is sent to the request, because that's fairly common, we might use one IP, one port for different fully qualified domain names. Well, based on the fully qualified domain name, I'll send it to a particular rule. So I can have one IP, so it could all be 443, for example, but I have different sites sharing it. We have that server name indication that we can put in the header. So I could do different things based on that. And again, at the listener, I can do things like the SSL offload. I have my certificate kind of management up there. And so then the listener is using a particular rule. Now remember, my rules can do different things. So my rule could be a basic rule. Now, the rule could just, hey, I'm routing it through to a particular backend set. I could base it on the path. So actually look at the path based of the URL, not just fully qualified domain name. I can even rewrite. So I can change aspects of what has been sent to me, and then I'm sending it again. I have this concept of my backend pools. I also have HTTP settings. That the rule is going to use. So this could be things like affinity, encryption, other capabilities I want to expose of it. But the nice thing here is these backend pools, I have a lot of flexibility here. So these backend pools could be, yes, VMs, they could be virtual machine scale sets, but they can also be IP addresses, they could be fully qualified domain names, they could be app services. There's a huge amount of flexibility. So what this means, this could be stuff in Azure, but it could be stuff on premises. It could go and point to things that point sites like VPN or an ExpressRoute private peering, or even a public IP. This is way more flexible with what it actually will go and use to. There's health probes again that it's using to check, are these possible targets available that I can go and send it to? But if I'm layer 7, hey, I'm going to leverage those things. Great, that's within the region. I've made my service available. But remember, that was regional. What about globally? There are a number of different solutions here. Now, I don't know if it's most basic is the right word to use for this, but we have Azure Traffic Manager. So Azure Traffic Manager is DNS. It has a name. You talk to the name. It will resolve to one of the possible targets, which could be anything. It doesn't care if it's layer 4 or layer 7. It's just DNS resolution. So that's a global endpoint that it can do things like performance. So it would resolve it to the instance that's closest to me. Absolutely, I can do that. There's round robin, there's weightings, there's different things it can do to enable me to go and talk. And it could talk to Azure endpoints like a PaaS service, a web app, a public IP. It could just be any IPv4, IPv6 or fully qualified domain name. It could be a nested endpoint. It could talk to another traffic manager, which maybe uses a different method to distribute the traffic. But this is just DNS, and there's a number of routing methods. We go and look. So it's talking about priority, weighted. Again, performance is very common. That's going to send me to the closest one, but I could restrict it to geographic. Multi-value subnet says just a whole set of things that I can do from that. And one of the things I would do is I can set a time to live on the record, which is how long it would cache it for before it goes and says, hey, is there a newer one that I want to do? Then let's think about this layer 4. Did I forget to write 4? Layer 4. At the same layer 4, well, one of the things we have now is a cross-region load balancer. So this is a global IP address, public, has to be public, that can then point to n number of regional load balancers. So it's any casting the IP. It's available in lots of points of presence, the Microsoft WAN outputs to. One endpoint clients can talk to, and then it will point them to, hey, one of those ones that is close to them. And I did a whole video on this if you're interested in the detail. So that's a great layer 4 solution for public services that I want to then go and talk to a regional. Remember, the whole point is high availability at all of the levels. I want it resilient within the region, and then if the region goes down, I want it resilient from a global perspective. But it's in some ways maybe more common now. What about layer 7? So at the layer 7 level, what we focus on now is Azure Front Door. So Azure Front Door is our layer 7, again, public global load balancing solution. And this actually has a whole set of different things. Now, once again, in front of this, it has a WAF option to protect again against those common types of attacks that I may have on it. And once again, it can do SSL offloading, cookie-based affinity, URL redirection, URL rewrite, all of those great things. But if you think about from, again, that Microsoft global WAN that has all of these different points of presence around the world, what Azure Front Door does is a number of different things. Firstly, that IP address like this is anycast. So the IP address is accessible from any of these points. But if I'm the client, what it actually does is something called split TCP. So I establish my connection with this points of presence that will be close to me because they're all around the world. And I'll establish my TCP session and then my TLS session with this. So it's close communications. And then when I want to go and get content, again on the Microsoft Backbone network, wherever the actual resource is, it will go and fetch large blocks of the data. And then I can optionally turn on caching. So it's combining features of the CDN to add to this, so it can also cache the content. So after the first person tries to access it, the second person will be accelerated because it's caching it. But even if I don't cache, it's still going to go and pull large blocks of the data. It has multiple targets. So if one's down, I can go to another one. And it's really common. Those backends will be app gateways. Regional, global. So Azure Front Door is really useful for that. But they do have to be public. It's a public IP. It's a publicly resolvable DNS name. But again, this can obviously be across regions, zones. Don't have to even be in Azure as long as they have public connectivity. Now, again, there are different SKUs. It talks about Azure Front Door Premium and Standard. Don't really worry about Classic so much. But you can see all the different capabilities that are available. Path-based routing, rules engine, Microsoft managed rule set. So if you think about from a WAF perspective, there's included rule sets. If I'm using this premium SKU, you don't only have to create custom ones. There's bot protection available. Just different capabilities. You can go and read through that and understand all of that great stuff that you can do. So obviously networking was very, very heavy on this. I totally get it. But really with Azure, a lot of the big things is the networking. Like that's one of the biggest things to understand. And if you do understand it, it's super useful for everything you're going to do. But let's change track. So if that was our networking, give myself a lot of space. Well, we did a lot of stuff. Let's zoom out a second. All right, yeah, we'll start over here. All right. So let's talk about storage. Now the storage, there's a lot of different storage services in Azure. But typically we need durable storage. We need persistent long-term storage for various things. So if I think storage, the most basic building block we are going to have is going to be a storage account. And once again, this lives in a particular region. So I'm going to give it a name. It lives in a particular region. It has a certain performance. Now, most of the time, what you are going to create is general purpose V2. That exposes all of the types of blobs and queues and tables and files. It's the most common used. I wouldn't ever use general purpose V1 or the standard blob. You're just going to use general purpose V2. But then there are also, so this is kind of the regular, then there are also premium options. Now the premium are service specific. It's built on SSD type technology. So there's blob, there's page blob, typically you're not going to use that. And then there's files. One important point to know about premium files bills you based on the provisioned size, not the amount of data you write. Ordinarily, I pay for the data I write to the service. With files premium, I pay for the size of the share I create because the performance goes up based on the size. So maybe I'm creating a share of a certain size because I need the performance that associates with that size. So it doesn't matter if I write nothing to it, I will pay for the provision size of the share because that's where the performance is being driven from. So that's a really super important point to understand. Now, when I think about those services for a second, let's just talk about that. So the common services are Blob. And within Blob, I can think of Block, which is probably the most common. I put multimedia files, Page. We don't typically interact with Page anymore. Page is for random access. We used to use it for disks, but now we have managed disks. So we won't play with this a lot. But also Append. Append is if we just want to keep adding like logging to the end of something. But then we also have Files. This is SMB or NFS, file-based protocols, shares. I could have Table, which is really key value pairs of data. Table is a kind of an odd term for what it's really doing. There's no schema to it. It's just I want to add these key values to it. Then there's Queue. Hey, I'm writing some message, first in, first out, leveraging it for that purpose. So we have these different capabilities. And if we saw a storage account, in fact, let's just go and create one. You'll notice it asks me for the region. It asks me, is it standard or premium? If I select premium, then I have to say, well, what type? Whereas standard, it's not even giving me a choice. It's just saying, you should probably just use a general purpose v2. I can, through a template or the command, use a different type, but yuck, we generally just not going to do that. And when I have this general purpose, if I jump over for a second to Storage Explorer, so this is actually one of the great tools that we can use to interact. So I'm looking at a storage account, and notice I can see all of my types. I can see Blob, file shares, queues, and tables. I can see I've got containers with files in them. I can see maybe I've got a file share. So I've got images file share. I can see its content. I've got folders. I could have a queue, which I can write items to. I can delete items, so I could add an item. So Storage Explorer lets me do that. So I do test. So now it's written an item to it, and I could dequeue it. Yep, dequeue. Now it's gone. I could have tables, which again, there's no schema to this. But I have a partition key, a row key, and then bits of data. But I can write anything I want. When I do add, yes, it shows me ones I've added in the past for properties, but I can just add a property, anything I want with some value I want. So it's schemaless. It's really just all about key value pairs of data that I want to store. And I see this, that Storage Explorer idea. If I go back to my account. So I see the same basic viewing here, containers, file shares, queues, etc. And notice it actually has a storage browser. So it gives me a version of that experience in the portal as well. So there are a number of different tools that I can use and leverage to interact with this. So it's actually a pretty nice, and we'll come back and talk about this. Obviously, I can use APIs and other things as well, but it's a nice way to do that basic interaction. But the other key thing is we do have this idea of redundancy that we set when we create the storage account, and we can modify that post-creation. So I think about the redundancy of the data, so the resiliency of my data. We have a number of options on how that data is going to be stored. So my next thing is the redundancy. Now remember what we talked about. So if I think of a region, so storage account lives in a region, remember. That region, very commonly today, is made up of availability zones. So I could think of my AZ-1, 2, 3. And within there are physical facilities. Let's just say there's just one data center or cluster, whatever that might be. So when I have the reliability, the redundancy for my storage account, I get to pick. So the most basic is locally redundant storage, where there's always 3. There's minimum 3 copies of my data. So with locally redundant storage, there's 3, but they're within the same storage cluster. Then I could pick zone redundant storage, only in regions that have availability zones. Well, now my 3 copies are spread over the 3 availability zones. Fantastic. So that's resilient at different levels within the region. Well, what about if I want protection beyond that? So I talked before about those pairs of regions. So this is where this is used. So let's say region 2. Remember, region 2 also has some storage clusters over here. My next option that I can perform, let's make sure I pick different colors, is GRS. So with GRS, there's 3 copies within a certain storage cluster, and there's another 3 copies over here as well. So there's 6 in total. Now this is asynchronous. It's always asynchronous between regions. Asynchronous means when I try and perform the operation, as soon as it's durably stored to the primary, it will acknowledge it to the client that's performing the action. And then as quick as it can, it will copy it over and replicate it. Because the latency is high between regions, it would slow down my app too much to make this synchronous. So that's GRS. There's also the option of GZRS. So with GZRS, the 3 copies are spread over the 3 availability zones. And then there's 3, but it will be within the same storage cluster on the other end. So again, you've got 3 and 3. Always a minimum of 3, so now I get 6. I have that. There is a modifier. So my modifier is I can optionally say read access. Nope. Okay, that scared me for a second now. Okay, so optionally we can also say read access. And exactly as the name suggests, what read access is saying is that I can also read from the replica. Now, not files, but it does allow me to, for example, Blob. Hey, maybe I just want to be able to read from the replica in the other region. So I can leverage that. Now, there are other features. I can turn on things like hierarchical namespace, which then for the Blob, it's POSIX style ACLs, and I can leverage those things. Once again, we have firewall on the storage account, so I could restrict it to service endpoints or private endpoints. When I think of interacting with the storage, so I guess I drew this idea of obviously the portal. So I can always use the portal to go and interact with my storage account. But then really powerful is that Storage Explorer. It's a fantastic tool to go and interact. So go and play around with that. I can upload data, I can manipulate. There's also AZ copy. So AZ copy is a really powerful command line tool. Let me just show you the documentation on this. So AZ copy, I can upload, I can download. One of the other nice things it can do is something called a server-side asynchronous copy. And what that means is, imagine I was doing a large-scale copy between different storage accounts. Normally, when I copy data, I kind of download the data to my client and then copy it to the target. That's really inefficient if I'm trying to copy between storage accounts in the cloud. So an async server-side copy, it just copies it directly between them. So it's a really efficient copy. And there's also things like data box, data disk. This is a really useful way for large scale data migrations. I can get entire units or individual disks, send them to Azure data centers. They import my data rather than sending it over the network or send it back to me. So that can be a large scale migration capability. There's things like Data Factory to create pipelines, to bulk move. I can do extract, transform, load type things. There's a lot of different ways to interact. Blob Fuse, I can mount within a Linux file system, my Blob storage account, and lots of capabilities there. So different ways to interact with my data, but fundamentally lots of different services available. I get to pick my resiliency. Now, one thing we always talk about is optimizing our spend. If I think about blobs could be huge. I might have lots of image files and different media. So I pay for the capacity I use, but I also pay for the interactions with it. So one of the things we can do with Blob, it's a different color. So with my block Blob, I have the ability to tier. And there's 4 tiers that we have available. So let's use all of our colors. I have hot. I have cool. I have cold. And then I have archive. I can set this at a per blob level. Now, why we have these is think about my different requirements I may have. So there may be data I'm constantly interacting with. And so there's 2 dimensions to the money I pay. I can think about I pay for the capacity, the actual amount I'm storing, but then I also pay for the transactions, actually interacting with it. So with hot, I pay the most money for the capacity, but I pay the least for the transactions. Whereas with cold, I pay a very small amount for the capacity, but I pay a lot for the transactions. So it's a trade-off. Now, archive, it's super cheap, but there is no interaction. This is offline. To actually read the data, I have to bring it out of archive back into another tier. So the way I would use this, if it's data I'm constantly interacting with, hot would make the most sense. If it's data I interact with occasionally, it may be cool. If it's data I never interact with, but it has to be available instantly if I needed it, I would use cold. If it's data I have to keep for a long time, and I could wait maybe 12, 13 hours to be able to read it because it takes time to bring it back, then archive. So it's all about optimizing how I want to spend my money. And the pricing would show this. So here, if I look at the pricing, and obviously there's that premium blob as well where I pay kind of the most, but you'll notice the pricing goes down as I move from hot to cool to cold to archive. But if I then looked at the operations, it gets more expensive. Hot's the cheapest, then cool, then cold. And then archive, well, that's about bringing it back out of archive. But also realize there are minimum amounts of time. So if I think about, where'd it go? The time, here we go. There's early deletion. So it has to sit in cool for at least 30 days. It has to live in archive for 180 days. And it has to live in cold for 90 days. And if I was to delete it out of there before then, it would still bill me for the remaining days that it has to be in their minimum of. So there are minimum times I have to keep it in those particular tiers for. So it's important to understand that when I think about picking my tier and how long I'm actually expecting it to live in there. And if I was to look while we're in here, I can completely mix it up. So in this one container, I've got some files in hot, which is my default. I've got some in cool, some in cold, and one in archive. And the key point is I could interact with any of them except the archive. If I try and access the archive, notice download is grayed out. I cannot download it because it's offline. I would have to change its tier and bring it back into another tier to be able to read from it. And that operation could take hours. Whereas with all of the others, I've got a download button. So even if it's in cold, I can still go and download it. It is available online. So I use the tiers to optimize that. Now, I can manually set this tiering, but that gets kind of cumbersome to do. And so what commonly we're going to have is lifecycle workflows. or lifecycle management. So what lifecycle management this will let me create rules to say, hey, based on maybe filters based on its name, based on last time it was accessed or modified or created, I could move it between the tiers. Maybe I'll even delete it after a certain amount of time. So I can completely automate all of the different aspects around that. And I'd want to make sure I respect those minimum times, remember. But here, if I jump back over, if I look at lifecycle management, I've created different rules here, but I've got move data for access tiers. And so I've got things that, hey, if I've not accessed it for 15 days, move it to cool. 45 days, move it to cold. 135 days, move it to archive. So you can create rules. I can create filters based on, hey, bits of the name. I could use a blob index key. So there's different things I could use to control how I actually want to use those different things. And I didn't show it, but on that redundancy side, just FYI, I can trigger the failover. And it will show me how up-to-date the replication is. So the last time in my time zone was 7:23. So right now it's about 2 minutes ago. So there would be a chance if I did that, there would be some data loss of stuff that was past that point. So I can manually trigger those different failovers. And then there's also features like versioning and soft delete and change feed for a whole set of those different things. The other thing you can do is object replication. So maybe I don't want to be stuck to the paired region. What object replication does is it enables me at a container level. So I could pick a different storage account anywhere. And I can say, look, stuff from this container, I want you to copy it to this in that container. And I could add filters to what it's going to control. So the whole point of this object level replication is that ordinarily, as we talked about, what it is doing is to the paired region. So this is the key point here. This is all about the pair. I can't configure anything else beyond that. But what I can do with this other capability is now, if I think about, I have my storage account and I have my different containers. So container 1, container 2. Well, I could have a different storage account anywhere I wanted. So this is storage account 2, and it has a container. And another storage account. So this is storage account 3, and it has its container. I can create my own rules to say, well, everything in here, copy to there. Everything in here, copy to here. Different regions, I have complete flexibility. So that gives me a lot more power to modify how I want that actual replication to go. So that's a nice thing that I can do from the blob. Moving on, that was all about blob. And again, there's a ton of features about protecting the data and being able to restore it and monitoring change feeds. Realize another huge service that we think about all of the time is Azure Files. And just like, let me give myself a bit of space. So if I think about files, go over here. So we have the same capability of tiers. So we have transaction optimized. We have hot, cool. And once again, the idea is we're trading off between the idea of capacity and the interactions with the data. There's also that premium, which is obviously a different type of storage account that we have to create. And once again, I can do things like soft delete on the file share. So look. So one of the nice things here, for example, is if I was to look at my files. So if I just go and look at my images, we can see for example, here I've got different capabilities. I've got the performance that I've got configured. I can have backup snapshots, so I can configure snapshots. So I can go and see a certain point in time. I've got soft delete, so I can undelete things for up to 14 days. And that could be between 1 and 365 days. So I've got the soft delete. So I can easily go back in time for those different capabilities. I can use a backup vault to orchestrate those snapshots that are being created. I can integrate with Entra ID, so Azure AD, for the data plane controls and access to that. And I should have pointed that out with Blob. So all of these things now, I can also do data plane permissionings on. But one of the unique things you may have with file shares is great. I've got my file share in Azure. So I can think about, okay, here's Azure. I created my Azure Files SMB share. Fantastic. But you may also have on premises, on my Windows file server, I have a file share. And maybe over here on a different location, I have a Windows file share. One of the things I can do is we have something called Azure File Sync. And what I can do is I can create a sync group. And exactly as the name suggests, these can now synchronize to the cloud endpoint. Now, they're not replicating to each other. Changes go to here, and then they can be read from the others. And I can have up to 100 of these, and it's always one cloud endpoint in any sync group. But the other nice thing I can do is imagine I have a lot of data, and I've got a finite amount of space on my physical file servers. Well, I can do tiering. So I could say, hey, look, when I'm down to X% free space, the least used stuff, just go and tier it up to here. It'll still have a thumbnail, a link to the data, and it can pull it down if someone tries to access it, but it can offload it up into the cloud. So that gives me obviously a really great capability for infinite scale, fundamentally. And that's really what I would want to be able to do. I can migrate later, gives me a good DR capability. If this goes down, well, I can still go and get the data, enable access to there. The other thing, security. So on this storage account, what you actually have is the idea of you have 2 access keys. Now, the reason you have 2 is I'm using one. I want to regenerate to change the other one. Once it's changed, I'll start using the one I've just regenerated. Now I can regenerate the first one. So you have 2, so I don't have to have an interruption to my interaction with the services. But these are all powerful. What's preferred these days is, remember I talked about the data plane. Most services now have a data plane role-based access control. So a blob data reader, queues, and you'll see this on the accounts. So if I was to go and look, so let's just go back up to the storage account level, access control roles. One of the things, let's just type in the word data. Notice we can see all these here. So I have blob data contributor, blob data owner, blob data reader, file data, queue data, table data. So all of these roles enable me to give Entra identities, be it users or service principals, doesn't matter, permission on the data plane. So I don't have to use what are these all-powerful access keys. And notice it gives me the option to rotate them. I can block them. Now I can completely block them. If I look at my configuration, one of the options we have is allow storage account key access. So I can disable it. One thing to bear in mind, another capability we have is we can generate something called a shared access signature. Now these can be at the account level or they can be at the service level. But these are signed by the access key. So if I disable the access key, I can't use service those signatures anymore. So realize, yes, these are not ideal to have, but if I disable them, I can't use a shared access signature. And so those shared access signatures are about giving more granular access to a particular service. So if I was creating that, for example, so if we looked at the storage account level, well, then it's an account level signature. So if I right click and say I want to get a shared access signature, again, I can do this from the portal as well. But if I do this, I can pick which services I want to enable because it's at the account level. All of the things I can pick which permissions, which times, which IP ranges, very granular. Or I could dive into a particular service and then I can create a service shared access signature. So it's not asking me what type of service, but I'm just setting, well, what properties, what do I want to allow? How long do I want this to be used for? And this is signed by there. So shared access signatures enable me to do a more granular set of configuration to that. But if you disable the access key, I can't use those anymore. So just something to understand and make sure you're leveraging that. The other thing is encryption. So by default, the encryption is using a platform managed key. So that's Microsoft managing it. You can do a customer managed key. Customer managed key means you're going to have your Azure Key Vault and you're going to have a key, and that's what you're going to use to encrypt. You are responsible for the rotation of that. Now I can use Azure Key Vault auto rotation policies to do that. I can use Azure Policy to alert me when there's less than 30 days left. There's things I can do, but you would then be responsible for that. There are encryption scopes. Encryption scopes let me use a different key for maybe particular containers or even particular blobs if I don't change it at the container level. So what that does is it says, hey, I'm on the storage account. If I look at my encryption, notice I can define encryption scopes. So an encryption scope could use a different key, which is what I've got here. And then on a particular either container, I could pick, so I've got special scope on this one. If we look here, properties, we can see I'm using a different scope. But also when I upload a blob, if I haven't configured a special one on the container, so if I just pick one that's the default, as part of the upload, I could pick a different encryption scope. So at a blob level, I can also use a different key. So this would be useful. Imagine I was an ISV providing a service to my customers. I might want to use a different encryption key for each customer, but I don't want to have to use a different storage account. So encryption scopes enabled me to have a more granular set of encryption. So I can configure that at a more granular level. Okay, so that's storage accounts. When I'm using VMs or many other types of resource, I talked about page blobs and how we tend to not use those so much anymore. The reason for that is what we use a lot today is the idea of a managed disk. And what's happening behind the scenes is there is still a storage account. So still a storage account. There is still a page blob, but it is completely abstracting it away from me. All I see is my managed disk. I don't care about the page blob. I don't care about the storage account. It's abstracted away completely. Now there are different types. So we have the idea of standard hard disk drive based, a standard SSD based. Then we have the idea of premium SSD. There's also now a premium SSD v2. And then we have the idea of ultra disk. And exactly as you're going to expect, it's getting better. So this is the best. This is the lowest latency, 0.5 millisecond latency, sub 1 millisecond latency. Who knows? The performance, there's kind of a line to draw here. I'm going to draw a line here. So when I think about performance, as the capacity goes up, so too does the performance. So the bigger the disk, the better my performance will be. Now, there are certain burst capabilities you need to be aware of. If you go and look at the documentation, it will talk about there's a certain amount of free burst you get. There's a certain paid that I can do for premium SSD. Premium SSD, I can also pick a different performance tier because you can't shrink disks. So the whole idea of being able to pick a performance tier would let me heighten my performance temporarily, because then I can shrink the performance tier back down again. Whereas I couldn't just make the disk bigger and then shrink it. You can never shrink a disk. You can only make them bigger. If you wanted to shrink it, you'd have to create a new one, copy everything over, would be super, super painful. So we would think about that. So the performance is tied to the size of the capacity. And we'll see this in the pricing. So if we go and look at pricing, notice as the disk gets bigger, so too does the performance. And as I go from, what is this? I notice it talks about bursting, so there's burst capabilities for some of these things. Premium SSD, V2, I don't look at that yet. Standard SSD, again, bursting capabilities. The bigger the disk, the better the performance. Now you'll notice SSD V2 doesn't have that. It separately talks about IOPS and throughput, as does UltraDisk. There's a maximum, but I pick the IOPS and throughput I want. So what's very different here is under this line, for Premium SSD V2 and UltraDisk, I pick the capacity, and then I pick the IOPS, and I pick the throughput. Now, up to the limit, the capacity still drives what the biggest it can be, but I could go smaller, and I pay for this, what I'm actually using, but these are dynamic. I can modify the IOPS and the throughput at different times. Then there's a minimum time it has to be at a certain level. But maybe if I had some big batch job, I can boost the performance temporarily to meet whatever my current requirements are and then shrink it back down again. I can do sharing for the standard SSD, and above I can have multiple different things connecting to the same disk. So that's a great capability. I guess the final thing to talk about for the managed disks is the encryption. So remember, on a storage account, we could just use customer managed key. It's a little bit different from a managed disk. So from a managed disk, what happens is I create something called a disk encryption set. That disk encryption set is using a certain key in my Azure Key Vault. And then what I do is my managed disks are placed in that disk encryption set, and then it will use that encryption key. So that's how I use my own encryption with managed disks. I create a disk encryption set first that uses my own key, then I create the managed disks or put them into that set. So that's at the disk level, encryption at rest. My other option, obviously, could be, well, okay, I've got a virtual machine. That virtual machine is running a certain operating system, and I could do the encryption within the guest. So for Windows, that could be BitLocker. For Linux, that would be dmcrypt. And this is what we call Azure Disk Encryption, ADE. So it still will go and talk to Key Vault to store the keys it's using, but the actual encryption in a lot of ways is transparent to the disk. It's happening inside the guest. That gives me maybe a little bit more flexibility in terms of the encryption and how I'm doing it. But also there's more constraints on how I can move things and manage them in other ways. I think a lot of times now people we'll use the disk encryption set instead. I can pair this with encryption at host. What encryption at host will do is the cache files on the host that's running this VM. So there's obviously a physical host running this thing. What encryption at host does is any cache files, it encrypts with the same key. My temp disk, it would encrypt with a platform managed key. And it will also encrypt the data in transit. So it would encrypt that data encryption going from the disk to the host as well. So encryption at host. Adds kind of that encryption and that. So the encryption over the wire. So I could combine encryption at host with disk encryption set to now it's always encrypted, which is probably something very useful we want to do. And again, I'm going to pay for the size of the disk I create. That's the key point here. Okay, so that's storage done. Okay, let's get back to a place. This board's getting very, very full. I notice the performance is starting to waver a little bit. Hopefully we'll make it through to the end. So the next thing I want to talk about is on the compute side. Now, I guess before I go into detail on the compute, realize there's different ways that we can provision our resources. So if I think about provisioning, I don't want to use the portal. And you might say, well, why not? I like the portal is very intuitive. But imagine at scale, I'm trying to create 100 resource in the same way. Clicking those buttons, even for a storage account, there's 10 pages of stuff to fill in. You're going to make mistakes. So we do not want to use the portal. Even things like the Azure CLI, PowerShell. I don't really want to use that to create things either, because yes, I can script it. I can use version control to make sure it's consistent. But what if I have to change the configuration? I can't just recreate the resource. It exists already, or error. I have to use a different command to modify. So we don't really like that either. The best way to do provisioning is we have the ARM JSON template or Azure Bicep. And Azure Bicep actually transpiles into JSON. And there are third-party ones like Terraform as well. There are other ones out there. But these are what we want to use to provision resources because they are declarative. We're telling it what we want, not how to do it. If I apply a template and then change something in the template and apply it again, it will make it so. These are really useful that I could put in my version control system, that I could then push with a pipeline. It will always make sure it matches what's in the template. This is what we want to be using. So if I was to jump over, and you should understand the basic format of these. The quick starts are fantastic. But if I go and look at compute, and let's find, there's normally simple Windows, VM simple Linux. This is what an ARM template looks like. Now, I've got these parameters, the things I can pass in at the start. And then what it's going to do is actually create the resources themselves. So if we look at the resources, well, it's from the Microsoft.Network resource provider. It's creating a resource called network interface. And then it's the properties that it wants to create. It's also going to create a network security group. It's also creating a virtual network. It's going to create public IP. Then from the Microsoft.Compute resource provider, it's creating a virtual machine. And the nice thing actually here is, it doesn't look very nice, but if you have an existing resource, most of the time you can look at export template and it will go and create this JSON file, this ARM JSON template for you. So it's generating the template right now that I could maybe go and use for my own purposes. I could modify it a bit. I can understand exactly what's going on. Normally this will just show, but it'll give me parameter options as well to leverage that. When I'm creating resources in the portal, often it will give me the option to, hey, show the template. So here's the JSON version of that. The challenge with this, as you're probably seeing, it's not very human friendly. And so that's why today we like Bicep more. This is creating exactly the same resource, but in a lot of ways, it's a lot easier to read. Okay, I'm going to create a VM. There we go. And I can take a JSON file and decompile it to Bicep. There's commands that enable you to do that. But this is far more friendly. So you should understand the basics of JSON and Bicep as the ways to provision them, why we like using them for our all-up sets of capabilities in Azure. And this JSON is actually how the back end of Azure is storing the metadata about all of our different services. Okay, but actual compute resources, once we provision them, and we can use this for VMs, everything we should do from a template. What are the types of service we actually have in Azure? And we always talk about these different levels of responsibility. And this actually could apply to databases and other types of service as well. But I can think layers. So I could think, well, there's storage, there's network, there's compute, i.e. the actual server running something, there's a hypervisor, there's an operating system, maybe there's a runtime, there's my application, and there's my data. And we're used to the idea that on premises, this is all my responsibility. I might have different teams doing it, but it's all my responsibility. In the cloud, we have different types of service. Now I could think about infrastructure as a service, a VM in the cloud. So here the line of responsibility is here. So now the vendor, let's say Azure, is responsible for managing the hypervisor, the physical servers, the storage, the networking. Now I still have to pick the right size and SKU, which controls how much resource it gets. But then I'm responsible for the stuff inside the OS. That means I am responsible for patching it. I am responsible for antivirus. I am responsible for backup. I am responsible for DR planning and replication. I'm responsible for anti-malware. Now there's things to help me in Azure. There's agents, there's extensions that can run a command. There's extensions that can run entire scripts. There are things to help me, but it is my responsibility to make sure I've got those things in place. Then we have PaaS. Now this could also include managed databases. Here, the responsibility is up here. So now I'm only really responsible for my app and my data, whereas the platform is responsible for all of these things. And when we think about the different technologies, right, this is a VM. This could be something like a virtual machine scale set. This could be Azure Kubernetes services. This could be app services. The ultimate would be serverless offerings like Azure Functions and Logic Apps. So there are different capabilities. But we want to try and get as far that way as we can. Now, to finish the picture, we also have software as a service. This is not Azure. This would be something like Microsoft 365 or Dynamics 365. Which is all managed by those teams. I'm still responsible for things like identities, but I'm not patching SharePoint. I'm not patching Exchange. Now, sometimes now there are extra functions where I could add on backups of some of those things, but primarily I'm not really responsible. There might be a bit of sharing for any of those layers. It's all just provided for me. And that's really the key point about it, these different types of service. And I want to be responsible for as little as possible. It's not me being lazy. For me, what differentiates my business from other companies is probably not the OS or the hypervisor or the runtime. It's the business value I can write in my application. So that's why I want to really focus my time. But it's super important to understand virtual machines. Although it's that leftmost service, lots of things are built on top of it. Now, when I think about my virtual machine, realize there's different dimensions to my virtual machine. So if I think about a certain VM, it has a SKU and a size. Now, it has dimensions. So if I was to draw it as a 3D box, one dimension could be CPU. One dimension could be its amount of memory. One dimension could be its storage characteristics. One dimension could be network capabilities. Another dimension could be it has special GPUs. I know I'm messing up the dimensions, but I can't draw in 4 or 5 dimensions. But imagine there's different aspects. And a common one might be the ratio. So it might be the number of CPU cores to the amount of memory. So I've got these different SKUs and sizes available. Why do I run a VM? I run a VM because I have a certain workload that I want to run. My workload has its own shape. If it's a database, typically it wants a lot of memory, a lot of storage throughput. If it's a batch processing, well, it's going to use a lot of CPU. So I want to understand what is the shape of the workload to map to the correct SKU of the virtual machine, because I don't want to waste resource. I want to pick the right SKU and size based on the type of work it's going to do. And remember, I picked the size as well. I want multiple instances so we can do scaling. I can add and remove them as the amount of work changes. So I don't just pick one really big one. I would rather have many more smaller ones. So based on the SKU, I'll make them smaller so I can have lots of them. So as the amount of work I have to do changes, I can add them and I can remove them to keep matching that. And Azure has that exact concept. So if I go and look at sizes of virtual machines, there are ones that are general purpose. So if I look at general purpose, I can see, well, hey, there's different sizes, but it's a 1:4 ratio of virtual CPU to memory. It has a certain amount of throughput, a certain amount of temporary storage. And it has temporary storage because it's the D variant. It has a temporary disk. And it tells me all the features it supports. Now, it doesn't support premium storage because it's not the S variant. The S variant adds the ability to use premium storage. But we can see it has all of these capabilities. It has different network bandwidth and NICs and cache disk, burst capabilities, normal, non-burst. I could look at the non-D version, and the non-D version doesn't have temporary storage. There's compute optimized. Compute optimized, the ratio is 1:2. I could look at memory optimized. Memory optimized, it's 1:8, CPU to memory. And also the storage and the network things change as well. There are ones with GPUs. There are ones that are optimized for storage. They have local NVMe drives. There are special versions of even the E series. There are these EB, and these B series have better remote storage capabilities. They have really high remote storage. There are things like the B series, which are burstable. So the burstable, instead of it having, hey, always this amount of CPU that you're paying for, you only get a certain percentage of the base CPU. But if I use less than that, it's like a mobile phone plan. I can bank credits. And then when I need it for a shorter period of time, I can burst up and use those credits I've banked. So I have the ability to exceed this CPU for a shorter amount of time. So it's really useful if I have some burstable workload, if maybe I want to, in a dev environment, hey, look, I want to try and minimize my bill as much as possible, then I can leverage that type of capability. Now, as this showed, I have also that storage capability for that virtual machine. So if I think about, I pick a certain VM SKU, realize that virtual machine is running on a certain host. So I think about, there's a physical host. It has a certain amount of local storage. I create my virtual machine. And that virtual machine, well, it connects to, remember, managed disks, typically for its OS for sure, unless it has the ability to use ephemeral. Now, if I have ephemeral, and that was one of those properties on the VM, the OS can actually run off of this local disk in the host, providing the VM it's either used for temp purposes or caching purposes. So if it's one of those little d, the variant, there's a certain amount of this is carved out and it's attached as the temp drive for the machine. Well, if I don't care about the state of the OS, I'm mass creating and deleting them all the time, I can save the money on the managed disk and use ephemeral. Like a virtual machine scale set, an AKS node pool, very commonly will use ephemeral disk if it can, because I don't want to bother paying for the managed disk. And it'll be super low latency, very high performance. I may also, remember, connect to other disks for data purposes. Maybe I configure different caching options on those. This is obviously completely optional, but I can leverage that. And then I can add various extensions onto this virtual machine for other things. That temp drive is D normally on Windows and /dev SDB on Linux. Again, only if it's that little D variant from that. Again, I talked about different extensions, and there's a lot of extensions available when I think of these capabilities. So yes, I can run a command. I can integrate with Azure Backup. So Azure Backup has a recovery. Let's just see this quickly. So if we look to the virtual machine, we'll see there are extensions. So I've got a whole bunch of them actually installed, but I can run different types of extension, which adds capabilities to this. So custom script extension, that's really useful to run a script on that particular workload. I can always run individual commands very easily as well with the run command. There's things like auto shutdown to help me save money because I only pay for the per seconds it's running. But notice I can hook into backup. I can hook into disaster recovery as well as part of that. I can have managed identities. I pick the size. I have inventory capabilities, huge amounts of features. But when I think of backup, if I go to my backup center, which is a central place that I can use for all of my backup management now, if I want to create a vault, there are two types. So I think it's more legacy. The recovery services vault supports these types of workloads. The newer backup vault, Azure Disks, Blobs, database for Postgres, Postgres Flexible, and Kubernetes services. So that controls the type of service that can be supported in the various types of vault. But Backup Center makes it very easy to centrally manage, centrally configure all of those different types of capabilities. And remember, when we create that virtual machine, we're going to want to be able to talk to it. But that's why we use things like Azure Bastion. I don't just give it a public IP and talk directly. It's a huge attack surface. I want to think about giving it through a managed jump box environment so it's protected. So that's where we use Azure Bastion. Azure Bastion is going to enable us to have that very safe capability. So virtual machines are great, but it's a single thing. It's an instance running on a host. Now that host we drew there is sitting in a specific rack. So I think about that rack is a certain fault domain. Now within a particular data center, what you'll often hear about is, well, I could have multiple racks. And you might say fault domain 0, fault domain 1, and fault domain 2. And we can use this with something called availability sets. What that does is as I add things into the availability set, it kind of round robins through the different racks. So it gives me resiliency from a rack level disaster. I never mix workloads in the same availability set. If I had a different type of workload, I would create a second availability set to make sure they are also equally round robined. If I put everything into one, bad luck, I may end up with all of one service in one rack, all of another service in another rack. So I would always separate them out. But my preferred approach these days, if it supports it, is remember in the region, ideally we have these availability zones. And remember, the whole point of availability zones is they isolate the power, the cooling, and the networking. And also the control plane as different fabric controllers. So now if I use these instead and I separate my resources over these, so I've got kind of a VM here, a VM in a different availability set, a VM in a different one here, that now the entire data center or a power substation could fail. Well, the others are still okay. So it's a much bigger blast radius I'm protected from compared to just running in different racks. So I'll always use availability zones over availability sets if I can. Now, obviously, if it doesn't support availability zones, which some regions don't, use availability sets. Wherever possible, this is the better option to give me the best possible protection. Okay. So a virtual machine is a virtual machine. It's one thing. But I drew this idea of more things to give us the ability to scale in, scale out. Well, how do we do that without me manually creating and deleting virtual machines? So what we leverage here is a virtual machine scale set. Now there's actually two types. There's uniform, which was our traditional type, but now we also have this concept of flex. But it both boils down to the idea of we're going to have this idea of a scaling profile. And the scaling profile says a VM template to use, the SKU, the type, the image, the configuration. I can set a minimum count, a maximum count, and then I can set scale actions. So for example, a good thing could be, hey, if CPU is greater than 70%, add 2 instances. If CPU is less than 30%, remove an instance. So what this is doing fundamentally is if I think about time, and then if I think about the load, the work I have to do changes, it's got some seasonality. Well, as those instances get busier and less busy, well, when it's quiet, maybe there's just a couple of instances running. But then as it gets busier, it has to add additional instances. Then when it gets quieter, it can delete them. So it can constantly add and remove. Now, although I drew it going up and down, we always think about it horizontal. So this is horizontal auto scaling. It's adding and removing them as the amount of work applies. That I hate drawing it that way. It's just it matches the curve better. Vertical is normally we would make it bigger or smaller. We'd make the SKU bigger and then make it smaller again. But that's pretty impractical most of the time because to resize a SKU, we'd have to stop the workload, change the size, and then start it again. So there'd be downtime associated. So typically what we want to do, I'm going to delete that because I hate it. I drew it to show it's aligning with how busy it is. What really we'll be doing is adding, so then's there, at the quiet time, it's only that many. So we are horizontally adding and removing, auto scaling based on those. So with uniform, we always have this. With flexible, what flexible does is I can optionally have a scaling profile. I don't have to, but I can also just add in regular virtual machines as part of a management profile. I could mix different SKUs. I could use Spot instances. Spot is the spare capacity Azure has that it lets you use at cheaper prices. And so that, again, could think about, hey, I'm trying to optimize my spend for maybe some dev workload or batch workload, something that can be interrupted and then resumed again. Spot is really nice for that. Or I can mix them in VMS Flex and still have that idea of that profile. Moving up the stack, we think about containers. And if you think about a virtual machine is virtualizing the hardware, containers is about virtualizing the operating system. Now, what we typically will have in the container world is we have a container registry. And a container registry is the images we're going to create our containers from. Now, typically we'll have some kind of base image. And then what we do is we write a Docker file. So a Docker file explains what we want our particular image to look like. We'll base it off of an existing image. And then we'll say the things we want to do to change it, add other layers, add software, run commands. And then now we create our own custom image. So this is our application image. And then we want to run the thing. So to run the thing, we have a container host. So now we have a certain container host. And the whole point of what this is doing is there's a kernel mode and a user mode. And what containers are, they're very thin. A VM is a complete OS. It's got its own OS image. It's got all the processes. It's a lot of overhead. With a container host, the kernel is shared. And then what it does is at the user mode, it uses different functions of the OS to create these sandboxes of where it actually runs a particular container image. So this would execute in this sandbox. So it's isolated at the user mode. It couldn't see the processes. It can't see the network of the other containers, but they are sharing a particular kernel instance. So that would be me if I'm just manually running containers. From an Azure perspective, the most basic service we have is an Azure container instance. So in Azure, it has its own Azure container registry. I can create an Azure container instance. And hey, this is where I can go and run my image, and I pay for the time it's running. I can group them into common groups. They have some shared concept of networking, etc. But typically, that's where I've got some fairly individual use case. I just need to run it basic. Maybe I'm bursting out for some level. But very commonly, I've got a bigger set of requirements. I need richer orchestration. I need more powerful scaling capabilities, networking, storage. So how do I manage lots of containers and make it resilient? So the solution is Kubernetes. So Kubernetes is kind of the de facto orchestrator for containers. Oh, that was wrong. And the Azure solution is Azure Kubernetes Service. Now, what this splits into two. So there is a management component layer, the control plane. This runs things like the API server that a component runs on each node pool that talks to the kubelet. There's an etcd database for the store. There's a scheduler that says, hey, we need to create some pods that host the containers. There are various controllers. In AKS, this is all done for you. You don't see this stuff. What you have is node pools. So you're going to create n number of node pools that, as you would guess, are running nodes. So n number of nodes. Again, you have that kubelet. This is all done for you. That is communicating to the API server to find out what it's supposed to do. It then creates pods, which is a container to run your, sorry, it's a container. It's the object that runs the container instance inside of. I can have the concept of persistent volume claims that can map to durable storage. So I might, hey, I need some durable storage. So that connects to a persistent volume. This could be Azure Files. It could be Azure NetApp Files. It could be an Azure disk. Elastic SAN, Azure Container Storage. So there's some specialist services coming out for that. But the whole point is I have now these are actually built on virtual machine scale sets. And these run in my subscription. I can see them. They're running those instances of the pods. There's different networking models for this because obviously it needs communication. The most basic one is KubeNet. It has a separate IP space, the pod C, but it has to NAT everything. There's lots of weird things I have to do with rules to make that function. So it's becoming a lot less popular. Then we have Azure CNI. So Azure CNI, the pods use the same IP space as the nodes, but that can get problematic from an IP space perspective. So then they added this dynamic capability to Azure CNI, where the pods now use a different subnet from the nodes, and it will grab them in batches. I think it's of 16 or something, but it doesn't have to pre-allocate all of them up front. But now the preferred one is overlay. So overlay uses a separate CIDR range for the pods, but it doesn't have the issues you had in the past of KubeNet. It uses its own native plumbing for the communication. And this is where people are trying to move to from that networking perspective of that. Realize scaling is still critical. So there's two dimensions of scaling here. The pods have to scale. So from a pod perspective, we have things like the horizontal pod autoscaler. So that's adding and removing pod instances as the work on the pod changes. Or newer than that, we have KEDA, the Kubernetes event-driven autoscaler. It's more powerful. It has more functions it can run on to decide to do the scaling. And if you think at a certain point, well, there's too many pods, we need more nodes. At the node level, then we have the cluster autoscaler. That if the scheduler says, hey, look, I've got pods I need to add and I can't because there's no capacity on the nodes, it can come along and add new cluster nodes. So they're scaling up both of those levels to facilitate that. One of the nice things you can do, imagine it's short-term burst, I need more capacity. Well, you can actually burst to Azure container instances. There's a virtual kubelet that represents ACI that would let me go and create my containers using Azure Container Instances. So those things can interact as well. And then if we go into more of the PaaS space, I'm going to go into less detail on this because there's so many of these. But maybe app service is the most basic one we'll ever see. This was one of the first services that existed. So with app service, you create an app service plan. And then in that app service plan, I can run a certain number of apps. App 1, App 2. And the key point is these basically are sharing the worker nodes that I create within my app service plan. I can have deployment slots. So I can have staging and production. But again, they're using the same sets of capacity within these. I'm going to create this. All of these kind of live within a region. I pick, is it Windows or Linux? I pick the runtime stack I want to use. There's the idea of an app service environment, which deploys directly into your VNet that has no shared components at all. If we actually go and look. So if I quickly look for app services, this is my app service plans. So an app service plan, if I create one, I pick the OS. I pick the pricing plan, And again, the pricing plan is going to dictate, well, there's different hardware, but then it dictates what features. So can I have a custom domain? I know it says free and basic. There's shared for some of these, depending on what I'm looking at. Is it zone redundant? Does it integrate with the virtual network? So I get different capabilities depending on what I'm doing. Like standard plans. There's different types of scaling. So rules is the traditional one where I configure how it's going to scale. But what Elastic does is this actually just looks at what is the HTTP load, and it decides how to add nodes. It can have a pre-warmed instance. So this is the automatic scaling. I don't have to manually define the rules. It's just going to do this for me. For some of them, I can have things like custom domains. I can publish data to this in a number of different ways. I could use a DevOps pipeline with get actions. I could point it to a URL. I could upload it with FTP. I could upload a zip or a WAR file. There's a huge number of different ways I can do this. But hey, I need to go and get my code into there to make all of this available to me. And I know this video was super long. I want to kind of finish off now. The next thing we have is monitoring. Monitoring is so important because we have to have observability. We have to know what's going on to be able to make sure we are healthy in the different things we're doing. And there's different layers of what we need to look at. So if I think of monitoring, think of the subscription level. So that first level is our subscription. Changes we make at the subscription at the control plane, well, they're going to show up in something called the activity log. And that activity log is available. It's free. I can see the things in there. If I could look at an individual resource or resource group, it will show me just the logs for that particular resource. But that's how I can see control plane things that are happening. Then we have the resources. Well, the resource has metrics, time-based signals, and these just get written to Azure Monitor Metrics, and again, they're free. I can go and see these about my particular workload. But then there's also logs. Logs do not exist by default. If I want the logs, what I have to do is configure something called diagnostic settings. And then I pick which logs, and I can take the metrics as well, I want, and where do I want to send them to? Now I could send them to Azure Storage. This would be an attractive option if I just want to keep it as cheaply as possible. So this is really cheap, but it's not particularly useful to interact with. I could send it to an event hub. This is a publish subscribe mechanism. And this would be useful if I had some external SIM that is going to go and subscribe and take the events. Or I can do any combination of these. I might send it to a log Analytics Workspace. So this is really powerful for the storage. Then it has really powerful analytics capabilities as well. So on this, I can do great analytics using KQL. So I can get great insight into the data. Now there's other things, there's like guest metrics, if it was a VM, there's guest capabilities, there's the Azure Monitor Agent. So once again, I can get then metrics from within the guest OS. I can get logs from within the guest OS. There are data collection rules. I've got a whole set of videos about this. But if I was to just quickly look at a resource, if I look at a virtual machine, it shows me basic monitors. So it's telling me, hey, do you want to enable some alert rules? I can see availability and CPU and disk bytes. I could go and look directly my metrics. So I could pick, oh, is it the host? Is it the guest? What metric do I care about? If it was a B series, I could see CPU credit information. There are ones that can split. So notice this is an aggregation, average use, but I could apply splitting and then I would see it based on the particular LUN that I'm using. So it will show me if it's splittable or not. But great levels of insight into that. But if I want to get additional data, I have to turn on diagnostic settings. Now, because it's a VM, I can go and grab different performance counters and logs and lots more things. But if I was to just pick something, let's say Cosmos DB, and I go to its diagnostic settings, here I add my diagnostic settings. What do I want to capture? So different category groups, different categories, metrics as well. And then where do I want to send it to? And I can create combinations of these so I can get that data and send it to different places. So I have control of how much. And I could also send things like the activity log. I could send that to a central location as well. But it's critical you have observability. There's layers I can go beyond this. So like App Insights will then go and look at the application running in the workload and then do synthetic transactions to test, is the application all up functioning correctly as well? So there's lots of different things I can do with this. But I can capture, I can run analytics, I can observe across all of these things. But maybe I don't want to just observe, maybe I want it to bring awareness to me. So one of the things I can also configure is alerting. So I can create alerts. Now, alerts can be based off of the activity log. Alerts can be based off of these monitor metrics. They could be based off of queries I run against my log analytics workspace. They could hook into, if you've got Azure Sentinel, then that's running its own workspace. There's many different places I can use these, but I can create alerts, and it recommends alerts to have, or I can add my own, based on the metrics, based on, do I find a result if I run this KQL, if I find an activity log that exists. There are basic ones, there are machine learning ones that looks at what's a common value, and then if I'm outside of a certain threshold, low, medium, high sensitivity, then generate the alert. And then once I have the alert, well, there's actually two things I can do here. Ideally, I create something called alert processing rules. So alert processing rules look to say, hey, look, an alert has been generated. Yes, it's showing up in a dashboard, but now I want to do something. Now, what I want to do is either I could go ahead and call an action group. Now, an action group could be SMS, it could be email, it could be call a function, it could be call a webhook. There's a ton of different things I can do here, but I could call an action group, or maybe what I actually want to do is suppress. Maybe it's Christmas, maybe it's the weekend, maybe if it's a lower priority and it's out of hours, I don't page people, maybe only if it's a certain critical. So these alert processing rules let me both call action groups and also I could suppress the alert being raised. Now I can also directly call an action group from an alert. It's just neater to do it via the alert processing rule because then rather than having for every alert, I might have hundreds of these configured. I have to manually say which action group. Instead, I can just raise the alert and now create an alert processing rule that says, hey, any alert raised that's of this type or for this group of objects, call this action group, call this action group. It's a neater way to organize them. And if we go and look, if we look at my monitor, look at my alerts. So we create the alert rules. So there's many different ones. I've got some based off App Insights, some based off of my subscription in the service health if something's unhealthy, the activity log, some based off metrics. We can define the action groups, which are things we want to do. And there's huge numbers of options here. So sure, I could, if we look at edit this, we can email, SMS, call an alarm role. We can also call a runbook, a function, hook into an ITSM to raise a service ticket, a logic app, a secure webhook, all of these different combinations of things. And then I can create an alert processing rule that can either say, hey, based on a particular scope, I define, do I want to apply an action group or do I want to suppress? I can set schedules around them. So it's a way to, based on those things, hey, actually go and perform some action. So I'm separating those things from each other. A final thing just to understand, super quick. When I think of a log analytics workspace, there's actually different types of workspace we have available now. So there's the common workspace we think about, which are the analytics logs. Now, this gives me the full KQL capabilities included as part of the cost. What I pay for in all of these is the data ingestion, and I pay for the storage once it's past the included amount of time. But this could get really expensive. So the other type we now have is basic logs. Now, basic logs have a subset of the KQL. I have to pay when I run them, and I have to pay for the storage, and obviously I still pay for the ingestion, but it's 8 days. That's all I can store. And then both of them can now write to archive. Now, archive can be up to 12 years. I pay for the amount of time I keep it. So these can go, if I want to store it longer than 8 days or longer than my retention here, it will go and write it to archive. I just pay for the storage, but I can't do anything against this data. If I want to act on it, I have to either run a search job or a restore job. And I have to pay for those. They cost money. Then it will bring the data back into here so I can perform operations. This subset of the KQL, I can't do cross-table queries. But one of the nice things is things like Container Insights now lets me pick a V2 schema that everything is in the same table, so I can use basic logs for that. So it's a way to control my cost for these. We can see it if you look at the pricing, that basic logs are cheaper, but yeah, it's only 8 days. Where it says 12 years, that's because it's going to put it in archive past the 8 days, but I have to pay for the queries. Whereas analytics, it's 30 or 90 days, 90 if I have Sentinel, up to 2 years interactive, but up to 12 years the archive. I can do alerting based on it. There's the archive fee, but then I also have to pay for search jobs or restore jobs. Then I also have to pay for basic if I run a query against it. So we can see these different types of fees apply depending on how I use that. And if I was actually going to look, so let's have a look, Analytics Workspace, and let's just pick one. Look at my tables. When we look at a table, so I don't know if I have a container V2. So the nice thing about the container V2, let me just scroll. There we go. If I run these 3 dots, I can manage the table. So currently it's analytics, but I could change it to basic. Notice it's got this interactive versus archive because it's set to 30 days. Remember, basic is only 8 days. So if I change it to basic, well, it will now put 22 of it in archive because I set my total retention to 30. If I change that time to further, it's more of it will go to archive. If I change it to analytics, well, now 30 will be in interactive, 60 would go to archive. So I can control how I want to use that actual storage. And Finally, I guess while I'm in this screen, the other big thing we're typically going to do from a networking is we're trying to troubleshoot. We have something called Network Watcher. And Network Watcher gives us a lot of capabilities around the overall health of our network. So I'm looking at my insights for just some basic information. But now if I actually dive over, let's look at Network Watcher. We have these different sets of capabilities. So I can view the topology is one of the things we have within here. Got this topology view, but I can do things like IP flow verify. So that says, does a security rule exist that would block this communication? I can do next hop, show me what the next hop would be, VPN troubleshooting, the health of the gateway, connection statistics, NSG diagnostics. It uses flow logs to map the various IP traffic. I can capture packets for troubleshooting purposes. There's a connection troubleshoot, which uses an extension into the resource to actually try and do a synthetic packet to see if it would work for it or not. So it's just really useful ways to troubleshoot the all up environment. And that's it. So that's everything I wanted to cover. Now, obviously, we covered a ridiculous amount of stuff in what is a very long video. Again, as I've mentioned, my recommendation would be make sure you go through the Learn modules and you've got as much hands-on as possible. When you take the exam, don't panic. If there's something you don't know, try and eliminate the obvious things and then just make an intelligent guess. Microsoft don't create functionalities to confuse you. They're going to try and make it as logical as possible. So think logical, but make sure you've actually done these things. It might have a series of steps, put them in an order you need to do. But just think what makes the most sense. How would I want to do this? And don't panic. If you don't pass the first time, look at the score report, see where you're weakest and go and redouble your efforts there and you'll get it the next time. So I hope that was useful. Good luck.